I mentioned, my name is Royal Hong, and I'm all of you. I think hopefully all of you can see me. I'm using multiple screens at the moment. By the way, can I just have a show of hands if you all can all hear me and see me as well? There's a few of us just to feedback. Okay, cannot hear clearly. Uh, I'm practically at maximum. Anybody cannot hear me? Can sound is a bit soft. Okay, let me just quickly. So that all of you can, because yeah, I'm going to take you for the next couple hours. Hello, is this any better? Okay, sorry about that because I actually got more than one camera set up also. Uh, so it was using the mic from another camera. Now, okay, I want to see the chats that are going on because you see, I need to. It's good to have feedback. Okay, it's very important to have feedback. So please use the chats. Tell me something if let's say I'm too soft, too loud, or what. Tell me about it. I'm having a look at the chat from another screen. Okay. Okay. Now, just a quick. I know there are lots of you here today. There are almost 500 of you all, 498 participants. So I'm not going to be able to know all of you, of course. And let me see. Can we have just a quick question to Yasmin? Is there a way for them to do something like a poll? So let's say if I ask a question, just a yes or no one, then I can see the feedback from them.
Oh, it's actually from the chat box cam, but I need to ask my team can work on it. Give
Oh,
us a moment first.
I see.
Yeah. We can see it.
Can you just find out? Because sometimes I would like to find out, like, for example, I want to see who is from CS, who is from engineering, and so on and so forth.
Oh, yeah, sure.
So that I can type something and just have a rough idea.
Oh, okay.
Okay. So can you find out for me if I can do that?
Yeah, sure.
Okay, thank you very much. And if any of you know that it can be done or cannot be done, you can just inform me, just put it in the chat, okay? Okay, now, you have heard a lot from those people in industry like Dr. Shan and so on, Dr. Saleh. So they are talking about the IC design and embedded systems. Now, just a quick intro of myself, okay? My name is Ryan Ong. I've been involved in computers for a good part of 40 years. Okay, it does sounds like I'm very old, right? Okay, and I've been involved in electronics for 35 years and embedded systems for 25 at least. Okay, so when I deal with embedded systems, I'm not talking about just your simple Arduino devices and so on. I'm talking about hardcore embedded systems like what you have heard from the uh, previous presenters and so on, whereby we are talking about reliable embedded systems. Now, the hardware aspect is one thing. Like, for example, if you build a chip for a car to use in an automotive environment or to use in a set for satellites, you heard also they've been used for satellites. Those ICs, they have to be, especially for satellites, they have to be radiation hardened. For cars, it has to be able to withstand high temperatures, low and high temperatures. Of course, those ICs that are made for your normal consumer usage, probably 0 to 70 degrees is already fine. So the ICs themselves have to be reliable in where they need to work. So that's the hardware aspect of it. Likewise, the software aspect of it is equally important. Okay, hardware is one thing, software is used to drive a lot of your hardware. You have heard from the speakers today all about embedded systems and so on. Okay, now I have so as I said, I've been involved in embedded systems for a very long time. I was a lecturer before at the University of Leicester in the UK and Monash University, Malaysia. Yesterday, one of my ex-students, Ku Kailek, gave you a presentation. Okay, he's working AMD. Last time he was working in Dell, now he's working in AMD. He was my ex-student. Now, as I said, I don't want to sound like I'm very old. I'm not that old, but basically I've been involved in this for a long time. I started when I was very young. Okay. Okay, yeah, some fellas are laughing. Yes, I started computing by the age of 8. I was already exposed to computers. Of course, at that time the computers are not like what you have nowadays. That time when somebody has my first computer has 16, not 16 meg, but 16K of RAM. K, kilobyte, 16 kilobytes. And then I had another one that was 48 kilobytes. And when you go from 16 to 48 kilobytes, is in the early 80s, it's like, wow, that's a lot. And then when I got my PC, I had another one. When initially I was using Apple II, then I went to the PC, and that time the PC was, I had 1 megabyte of RAM, and that was fantastic. Okay, those were the days I started computing. Maybe one or two of the presenters that have presented, they may have even gone further back to the point that they were dealing with punch cards and so on, but I didn't go that far back. Okay, anyhow, I've been involved for so long. I've been a lecturer at the University of Leicester and then Monash University. And for the last 15 years, I've been running my own small company, Proven Packs and Ramberhart, which we deal with no prizes if you guess it correct. We deal with embedded systems. Now, I'll show you what it's like basically. Okay, so let me see. I should be able to switch to another camera. Now, this I didn't use a ASM background. I want to show you roughly how it looks like in my office. I'm in Puchong, so my office looks like this. I will show you on another camera. Quickly show you first, so that to give you an idea what embedded systems can be doing. Okay, let me see. Okay, so that's another part of the office. I think you can see it from here. And I'm just moving the camera a bit. That's another work area that is full of components and so on. You can see component racks on the wall, projects behind. In a distance, if you look at the blue, something in the middle that is a bit bluish, that is a pick and place machine that allows us to build simple to populate simple PCBs. Actually quite complex. We do SMDs and all these, but except that we don't do it until very fine geometries. It's good enough for us to do most of our stuff. If the more complicated ones, we send out for production. Okay, and nowadays, like what a lot of your the speakers have mentioned in the past, embedded systems is a multidisciplinary thing. So if you can see, I got 3D printers, I got even more 3D printers, I got even extruders for plastic injection molding, because for us, when we deal with our clients, sometimes they need casings and all this, so that's where we build it in together. So this place is a bit like a one-stop solution, IoT one-stop solution, end to end. Okay, so I'm going to bring the camera around. You can see, so I showed you some embedded systems and so on. Some of the things that we are building, you can even see a drone on the table, not yet completed. You can see our cabinet there that has quite a lot of chemicals and so on. So we sometimes have to use quite a lot of chemicals here and there. So chemical cabinets and so on. And a bit nearer here, this is my actual work desk itself. So you can see quite a few different embedded systems. One of these, this one is dealing with the Ministry of Health to build. We are building some special equipment for them. This is another one. This one looks like what you know, it's a pulse oximeter, but it's a special one. It's not your normal one. It has been retrofitted, so that's completely different from the normal one. And in fact, it allows us to measure quite a lot of parameters. Okay, so after I will quickly show you this one to give you an idea. Now, I deal a lot with reliable embedded systems. So reliability is the main thing. And for these next few hours, we'll be doing something basic, but dealing with make it reliable. We are going to do something simple, but we'll make it reliable. Okay, let me just switch back to my normal camera first. Unless you want to see a bit more of the lab, okay. So we got quite a lot of equipment in the lab. This is what you expect. Some of it you won't expect, like CNC machines. We also have it. We need it. That is a true embedded lab, like cutters, saw, all this. So we have quite a lot of equipment in the lab to do a lot of things. Okay. And even behind me, there are like vacuum machines and so on. Not vacuum cleaners, vacuum machines. Because when you do embedded system, like for example, if you're dealing with, say, an environmental system that you have to build, you actually have to be able to model the environment, to take measurements and so on. So that's why we have this. Like for example, our aqua system over there, that one over there is to measure the water parameters for aquaculture. That's why you can see in the cabinet in the distance, there is quite a lot of chemicals in there, because those are the things that you expect to measure in an aquaculture system. So we have to emulate it in the lab first to make sure that it's proper. Okay, so not just simply building a system using Arduino or whatever, but we have to make sure that it works properly. And I can tell you, in a lot of cases, building the system is only half the story. The deployment aspect takes up a lot of additional time. It's during the deployment, especially as the first time you're building a system, that you find out a lot of the issues behind it. I give you a very simple example. You have heard a lot of times people say, hey, you want to do, you remember, like in Kelantan, Terengganu, all this, every year it floods, right? So you have heard our government has like building flood monitoring and all this. Agree? You all heard before? Flood monitoring system so that they can give pre-warning and all this? Heard before? Right. Okay. What's the main problem? Normally all of these systems work on the desk. But when it comes to deployment, you may have reliability issues. And what are some of the causes of reliability? Okay, you are monitoring a river, you have to go upstream. Upstream there, communication may be sparse. You may use in satellite communication. You may have cellular communication, but you have to measure the river level and you put, let's say, a sensor in there. Okay, so you go and put a sensor. Okay, let me just take an example. Let's say I got a ruler here with me. You can see, okay, we put a sensor on top. We measure using ultrasound or what to measure. Okay, fine. After that, the monkey comes and start playing with it. Oh, shake the whole thing. Okay? It shakes it a little bit. If it tilts a little bit, your sensor is already measuring a different position. So you think that your sensor is measuring correctly, then the water level could be rising or could be falling. Actually, it's the whole thing that's moving. You put a nice solar panel on it to get all your power. The bird sit there and start shitting on your solar panel. What are you going to get? You're going to lose power. Okay, so a lot of these things embedded systems, building it reliable, it's not only a hardware aspect, it's a software aspect as well. It's a system aspect as well. You have to think about environment and everything that goes around it. Okay. Oh, I saw a question. Well, some people do industrial training in my company. We don't have many people. Sometimes we have 2 or 3 only of us maximum, because we build software in such a way that I got so much experience in doing it that I can actually come up with some things pretty quickly. But we have hosted previous batches of RSM students in our company to do some of the projects and all this. Myron mentioned, do you have an environmental testing chamber? Well, we can do environmental testing, but the thing is, when you are dealing with testing, you have to test the standard, right? When you test the standard, there's something like an IP standard, IP60 or whatever. If you want to test the standard, the chamber must be certified. So we can testing. I have a chamber, I got a chamber that you can temperature control and all this, but it's not certified. So what we can do for us here is we actually have it. Why? We pre-certified. So that when by the time we need to go to like CRIM or MIMOS or what to do the actual test, it should not fail already because we pre-certified, but our equipment is not certified. So we cannot like say, okay, you pass CE or whatever. Understand that? So when you build a commercial embedded system, especially for sale and all this, you have to go through the regulatory process. You have to get MCMC. If let's say you got Wi-Fi and all this, you need to go through MCMC approval and so on. If you're dealing with medical equipment like this kind of equipment, medical related one, you have to go to MDA and all and so on. So yeah, we have equipment that we can do a lot of testing, but no, we cannot do the certification ourselves because our equipment is not certified. Our equipment is used to give us the confidence that it will pass a certification. Okay. Now, I talked quite a lot already without even starting anything yet. I just want to quickly ask Yasmin, is it possible to use Zoom to do like a polling or something like that? If not, it's okay. But
as for my part, I cannot create the poll.
okay. Okay, never mind. Yeah, because 600 people,
Yes.
let's say 60 people, as you can see, oh, how many hands up for this, how many hands up for that? Okay, never mind. No worries. Okay, now we are going to do a little bit, as I say, on embedded systems just to get the hang of it. Now, bear with me. Some of you will say, this one is so easy. Done it before 20 times, 100 times, or whatever. Some of you will be struggling because you don't come from the engineering background. Maybe you're from computer science, IT, and so on. So I have to go at a relatively low level because your backgrounds are very diverse. Remember, there are almost 600 of you. Yeah, I must say we can use reaction buttons. 600 people, 600, but your 600 press at the same time, I also cannot see. Okay, just now that game where it will show you that score and all this, that would have been useful. Now, depending on the platform that we use, some platforms have voting platforms. Like for example, Webex allows you to do like voting. I ask a question and ABCD and I can see ABC on it. Zoom may not have that facility. Okay, so now this one is to give you an introduction. I think before you receive emails and all these. Well, I could make an online poll and send the link here, but by the time I do so, I think it will be a bit late already. Never mind. Now, I think you have been wait, the poll can only be set by the host or co-host. I should be a host or co-host, right? Anyway, never mind. No problem with that. Now, rather than just giving you something that is all in theory and so on, which all of you end up going to sleep, let's just do a little bit of hands-on. Now, I know I'm going to use the Arduino Uno. Now, some of you will say, huh, Uno, that's a very low-end embedded platform. The key is not whether it's low-end or high-end. The key is how you use the how you build. What I want to cover is how to build it in a proper manner. I'm not saying that Arduino IDE or Arduino framework is not proper. I'm not saying that. It has its users, but it has also got its limitation because you need to know that it's meant for very simple things. Yes, it can be used in a complicated manner, but you need to know how. But I want to use it for a very simple reason. If let's say your attend the embedded systems related training that I give all of it anyway. If you want to attend it, the NCEP with for embedded systems, we will use the Arduino Uno and we will use the Arduino IDE. But that's about it. We are only using the hardware and the software because the Arduino Uno hardware is relatively cheap. If your board burns, you don't need to pay $100, $30 already, you can get a board. You burn the board, you pay back, fair enough, right? Okay. The second reason why we use the Arduino IDE is because it's free. Okay. But we are not going to use the libraries or whatever. That's the key thing. So like last time when I gave the training, some of them said, oh, we learn Arduino Uno. I said, no, you use the Uno as a hardware. You learn a lot of things that are not in the framework or whatever. You learn the proper things to deal with reliability. Because at the end of the day, if you build something like this, okay, if you go and build something like this and you don't actually use it, or not say you don't use it, you build something like this, and if something hangs, what are you going to do? Take out a battery, put it back, then what works again? That's probably okay for this. It's not okay, like what you heard earlier, like cars. What if you ride the car? It's basically also an embedded system. Anything goes wrong with it, whoa. A car has the safe state for a car. It's not necessary to stop the car, If somebody program like a car and is going down the highway and something gets jammed, like an accelerator pedal reading gets jammed, you'll be traveling a highway 100 kilometers per hour. Safety is not to reduce cows, or maybe the car. So safety is not to stop. So reliability is very, very important in some embedded systems. Reliability is not that important in things like toys and all these, as long as it doesn't cause harm. But anyhow, our concentration is reliability. So basically, we use Arduino framework and all this, but our concentration is how we write to make it reliable. Okay, so you have been given the emails so that you would actually have a link to not the IDE, but an online simulator. Okay, so let me share my screen with you all. I'm going to share you got my slides anyway, so I'm going to start using the slides shortly, but let's share my screen also. Okay. I'm going to share this screen with you all. So I think all of you can see this screen, right? I'm at this website, wokwi.com. Anybody got problems getting there? Okay, can? Anyone got problems? The thing is, 591 of you participants, anybody got problem, I also don't know how to handle. 1, 2 problem maybe, but a lot of you there, okay? Anyway, as I said, please get to this website. If you have the link, it's wokwi.com. Let me put it in the chat so that everybody has it. Okay. Okay. Now, once you are there, I'd like you to click on Arduino Uno Mega Uno. Okay, once you're there, please click on Arduino bracket Uno Mega or Nano. Okay. So don't create a project that's there already. We want to just create a new project. So we start from scratch and we start with the Arduino Uno. Okay, ladies and gentlemen, once you get there, we start from scratch, start with the Arduino Uno. So if you have clicked followed what I've done, you'll get to this page. Now, those of you, hard to see how many of you are, okay? But maybe you can show either. I'm going to ask you a question. I said, I'm going to ask how many of you have done the Uno before? If you've done before, thumbs up. If you're not done before, thumbs down. Okay, just have a quick show. So how many of you have used the Uno before? Do you know Uno? Okay, wait, hold on a second. Some of because I'm sharing screen now, I don't see. Let's see. I can see from the participants list how many thumbs up, thumbs down. So the majority so far, 33 of you have been thumbs up. Okay, it's a majority. It looks like a majority have been thumbs up now. Okay, now never mind. Don't worry. Those of you have thumbs down also, don't worry about that. Okay, now importantly is, have you all managed to get to the screen that I'm showing? Where on the left you have the code, on the right you have a picture of the device itself. Okay, anybody couldn't get there, I can help one or two, but maybe that's the most because we only got 3 hours, so unfortunately, okay. Now, those of you who have done Arduino before, you know that if you start any new project sketch, you end up getting 2 functions. Oh, January, you are using mobile. Good luck. Try your best, but I think it is going to be a little bit tricky for you. Okay, so those of you have done before, you know that you got 2 main functions to start, which is setup and loop. Now, in IDE, behind the scene is actually a C++. In fact, the framework is written in C++. They just abstract certain things like setup and loop for you, so that makes it a bit easier. But basically, the frame is C++. Okay. Sudam, don't download the software. Just go to walkwin.com. Please check the chat. Okay. I put the link further up already. Can I pin onto it? Wait. I can't pin on the chat, so never mind. The URL is given in the chat. I'm going to repeat the URL here. Okay. Now, okay. We got as long as you can get here, we got our basic setup ready. Let me go to slides first to cover a little bit, and then we come back here to do what we need to do. You do not need to sign up. You just use it as a anonymous user. Okay. Just use it anonymously. If you want to sign up, go ahead, but I'm not signing up. Okay. This is the best way we can do because, as I say, we want to do a bit of hands-on. Okay, let me go to the slides. The slides. So we are doing the embedded C workshop. I believe all of you have got the slides too. Okay, I'm just going to put it this way. Okay, I'm going to go to full screen mode also. So you can see my PowerPoint itself. And okay, so what's an embedded system? You have performed this earlier today, what an embedded system is. So, 1 second. So basically, an embedded system is always a computing system. It's based on hardware. There's a processor or microcontroller or FPGA. They'll be running software, but the main difference is that software is going to perform one task. Okay, so your old phone, like for example over here, your old Nokia phone. I think all of you are too young to know about Nokia phone, right? Okay, anyhow, your old Nokia phone is an embedded system. It's basically doing one thing. Yeah, you can say we can play some games on it, but the difference is you cannot load an app. Okay, your old camera, those of you are old enough to have your cameras, that's an embedded system. What about Huawei? Okay, your smartphones, we won't consider an embedded system. It can load all kinds of software that you want. Okay, like your computer is not an embedded system. It is a computer. We generally classify an embedded system as it is a computing system, but it generally does only one task. That's the main thing. So how about calculator? Yeah, embedded. A lot of embedded systems, you practically all embedded system, if you want to upgrade the software, or use the word firmware, if you want to upgrade it, it's not going to be that easy. How are you going to upgrade the firmware for camera? Not easy. How are you going to upgrade the firmware for washing machine? Oh, not sure at all. Okay. But when it comes to smartphone issue, right? Look at new app and that's it. That's the major difference. So basically an embedded system. The software that's okay runs it. And if you want to change the software, it may not be the easiest in the world. And you probably cannot load new software and so on. So change chip. What do you want to change the chip for? Okay. Like AC vacuum robots are embedded system. Yeah, basically yes. Although nowadays it's a bit easier to upgrade the firmware, but your vacuum cleaner robot is not going to do other things like do your washing and so on, right? Yeah. So EV cars embedded, you can say half of it is embedded. The parts that control the car, ECU and all this, they are embedded. Okay, but your entertainment system, you can, let's say you can load new apps and all this into it, that I won't consider embedded lah. Okay. Rice cooker, yeah, well, depending on your rice cooker, we got very basic ones that don't even have any ICs in it. Semiconductor, yes. IC, no. Lift, can your lift become an escalator? Cannot, right? Embedded. Can your phone do other things? Take photos, blah, all this? Yeah, not embedded. Okay, now, would this be an embedded system? Standalone process automation controller. What do you think? Standalone process automation controller. Embedded or not embedded? It can be programmed, okay, but typically it's only going to be used for one particular setup. Automation controller. You program it, that's one thing. If you program it, you reprogram it, it's so typically these are also systems. The difference here is consumer and embedded systems. Okay, so industrial and commercial ones. You can see here the difference between the industrial ones and commercial ones. Okay, any questions so far? Any questions, just ask, put it in the chat. Okay, so this is just a quick summary to say what is the industrial versus commercial. Like for example, industrial ones are normally very much more expensive. Like you saw this slide. Oh, this is an industrial embedded system. 30,000 for this. But then it controls your production line and it is meant to be 99.9999, don't know how many 9% reliable. So that's the different things. These ones, they may be expensive. They control your production line. Your production line stops for 1 hour because you maybe use a wrong controller, chip controller or what. That's it already. The difference in cost could be there. Is, are other people getting problems in the internet here? Because I wouldn't be able to tell. Anybody else? Some people say they have problems with the internet. Okay. I got actually a fast internet. Let me just double check. Okay. Give me a give me a quick second. Because I'm actually running here on my machine. Okay, give me a second. Let me shut down most of the things that are running on my machine so that hopefully it will not take up so much bandwidth. Okay, as long as I have the important one here, that's good already. Okay, hopefully this is a bit better. Shut down my browsers until the minimum. The browsers take up a lot of processing, especially got a lot of tabs. Okay, any better? Okay. Yeah, my computer also doesn't feel so warm at the moment. Now, yeah, because I was having two browsers open left and right and so on. I got three screens. That's how we have to work. In embedded systems, you want to work fast, multi-screens, because you have to see this and that at the same time. Okay, I hope you'll remain better like that. Now, okay, very fast thing. We are going to use the Arduino Uno. Those of you who have used it before, you know that it's based on this microcontroller, the 80 Mega 328P. Now, of course, you all know it as Uno, Arduino Uno, but I know it as 80 Mega 328P. That's the exact processor or microcontroller that they are using. Okay. Now, we use a lot of microcontrollers. Nowadays, we even call them typically, even microcontrollers themselves can be part of the processor. So the whole thing becomes a system on chip. Basically, a microcontroller is actually a system on chip. Your original old style microprocessor is just a processor alone. Then you need other components around it. The IBM compatible, the original IBM compatible computer. It's just a processor, and then it has all the rest around it, which is a peripherals and all this, but they're all separate ICs. But microcontrollers are built differently because they are normally built with processor core, some memory, some IO, some peripherals. Yeah, you can say that processor core is not as powerful as a microprocessor. Well, subjective, but because nowadays the microcontrollers are also extremely powerful. Okay, because nowadays yung powerful and the that's from moon. Okay, so these are some of the things that we will cover during our normal training. But for here, I'm going to skip most of these. I just want to mention that, okay, when I teach embedded systems, we have to use the hardware, and we are going to use the Arduino Uno hardware. But that's about it, as I say, because now, from the software point of view, we are actually going into looking into the data sheet itself. Because what I find, I've been lecturing in the past, I've been dealing with a lot of fresh grads and all this. What I find in general is a lot of you have little knowledge on how to get the critical information from data sheets. Those of you at universities, you learn how to use Arduino and all this, you end up using only the libraries. Now, the libraries are built in, that's good. Okay, that gets you working fast. But then the fundamentals may be lost. And like one of the lectures mentioned to you, one of the speakers mentioned earlier, the fundamentals are still very, very important. Okay. My opinion is the vast majority will say they know embedded systems. Fresh grads, huh? You'll say, you know embedded systems. 90% actually don't really know enough on embedded systems to do it. Because you know how to use libraries and all this, but you can't get it from the original source, which is from the data sheet. So somebody asked, when comparing to CPU, how does microcontroller compare to it? Like it's just more pins and so on? Not at all. Well, you see a CPU or original CPU is mainly just to do is the ALU itself, just to do the computation. Then the rest of it is handled by other chips. Like for example, computation is handled by separate ICs. Like it's actually point one, but including the memory, also there is a trade-off. Memory, so it's a trade-off. It's for it's a trade-off. You get everything on board, but not like a lot of RAM, a lot of flash. You get a certain amount. Okay, that's a big difference. Yeah, I'm lagging, but if you say I'm lagging, I can't do anything much. It could be even Zoom system itself because there's so many at the same time. I do not know. Okay, now for the development tools for embedded systems, you have quite a bit of toolchain around. But as I said, we'll use the Arduino IDE. The only difference now for today is you're going to use it online. Okay. Let me just show you one very simple aspect of an embedded system, which is just to control the GPIO. You see, if on the embedded system, okay, let me go back to the chip itself. You know, the chip has the processing core, digital I/O, analog I/O. You have peripherals like UART, timers, and all these, and you got the memory, the RAM. Not only the RAM, but you also have flash all on board to store your code. Okay, now the key thing about a microcontroller, the very useful thing about it is compared to a CPU, MCU, microcontroller, the very good thing about it is you got the peripherals and all this built in, including IOs, GPIOs and so on. Your pure CPU don't have one, but microcontrollers were. So let's say you want to control the IOs, you want to turn on LEDs and so on and so forth. Microcontroller, you can do it very easily. Okay, but how is it done? Now, so maybe some of you can put in the chat, those of you who knows a bit about, let's say you want to, let's say you have to on GPIO, for example, you see, you can put it in the chat. Those of you who know. So in your code, you say you want to turn on an LED, can be any GPIO. You want to set the output high. What will you do? What kind of code will you write? Label. What function would you use? If you follow the Arduino framework, what function would you use? Okay, so we can see digital write. Okay, write to what pin? Set it high. Okay, good. Those of you who have done it before, you know that will be the function, but that's a built-in function. Now, any one of you can explain roughly what goes on when you do digital write. What goes on behind the scenes? You wrote that in software, but how come the hardware could work? I know you all cannot turn your mic on. Yes, you all can tell me set the signal high and so on. Okay. Okay, one of you said, okay, Desmond Ong said, register associated with LED is set high. Okay. That's where the embedded engineer comes in. This is where we will tell you, okay, now, let's see. Let me show you this. Some of you will say, hang on a second, what is this? Basically, this is the hardware for one particular bit of the one particular GPIO. Okay, you know, on the Arduino Uno, you got multiple GPIOs. GPIO stands for General Purpose Input Output. Okay, so it's a thing that can be made an input or an output, and it can also be made for other users like URM. Now, let's concentrate on input and output first. So it is a pin that you can destroy input and output. Now, in silicon itself, it actually looks like this. This is the hardware. Hardware in itself. So you can see you've got like resistors, but inverters, you have AND gates, D-type flip-flops, muxes, and so on, right? This is the physical hardware of the pin itself. You can see the pin is on the left. Okay. On the right, you can see the data bus. So how the software control the pin, either to make it input or make it output. And if you make it an input, you can read the state, whether is it high or low. If you make it as output, you can set it high or low. All of this, how is controlled in this hardware, but how does the software talk to this part of the hardware? Okay. So this part of the hardware, for this particular pin, 8 of them will be grouped together and they will be put into one register. So you can see like this one. You can see a few flip-flops there. They'll be all grouped together. And from the software point of view, we'll put it into what we call registers, or to be more exact, we call it special function registers. A register is just a memory location that you can read and write to it. Okay, it is a memory location. It remembers. So you write what value, it remembers. You read from it, you read what you have written to. Okay, registers are different from RAM. RAM registers are normally made from flip-flops, D-type flip-flops. RAM is made from SRAM or DRAM. The structure is different. Although they're memory, they are also memory, but physically they are made differently. Okay, they use the same process, but SRAM is made using like 4 or 6 transistors per bit. DRAM is 1 transistor, 1 capacitor per bit. Registers, however, you can see here, the D-type flip-flop is made from multiple logic gates. Yes, all of them store bits of information, but they are used, the structure, the circuit is different. Okay. Anyhow, now, just for one port, which 8 of the pins are connected to, for the GPIO on the ATmega323P, there will be 3 different registers. One register, I normally start with the middle one. We call it the DDR, data direction register, and various ports. Our microcontroller is one. It's only 8 bits. So every 8 becomes 1 port. Okay, so when you are using your Arduino, let's switch back to the Arduino. You can see here in this diagram, let me scroll it up. Can I scroll in a bit? Okay. You can see in this diagram, you got 0 to 7. The digital side, you got 0, 7, and then 8 to 13. Now, from a user point of view, you just call it 0 to 13, that's all. But the software that you use, if you use the libraries and all this, that 0 to 13 will not map accordingly. They actually map to two different ports on the microcontroller. One of it is port D and one of it is port B. Okay, so I call up port B. The reason is because port B over here, this particular LED, the one with the letter L beside it, is actually connected to pin 13, or what we call pin 13. That pin 13 is actually port B, pin 5. How come I know? It came from the data sheet itself, or the schematic of the Arduino Uno. So for those of you who don't know, never mind. I just tell you, this pin 13 here connects to this LED itself, and the register that controls it is port B. So this one is actually pin 13 is actually, this is port B, pin 0, pin 1, pin 2, pin 3, pin 4, pin 5. Port B pin 5 actually connects to this LED. So why I call port B out? Because we are going to use it shortly. Now, so port B pin 5 is actually going to be these three ports. Okay, let me, I know I can do drawing. Let's see. I share my screen. I should be able to. Oh, hang on a second. I'm looking for the drawing tool. Webex can draw. Can we draw on with Zoom? Not sure we can draw with Zoom or not, but never mind. Since I got Excel, sorry, I got PowerPoint here with me. Let me just do this. Okay, I'm going to do this. I'm concentrating on this. Now, I mentioned previously that we are going to toggle an LED on Arduino. We are going to toggle this LED. We are going to make this LED blink. Okay, this LED L here is actually pin 13 is actually, and this is actually pin 0, 0, 1, sorry, 2, 3. Oh, it's a bit slow. Hold on. Yeah, it's lagging. Okay, so this LED here is connected to Uno 13 or pin 13 on the Uno. Now, pin 8 to pin 13 is on port B. This is port B, pin 0, port B, pin 1, pin 2, pin 3, pin 4, pin 5. So port B, pin 5 connects to this LED. Now we want to make it blink. Okay, this is port B, pin 0, 1, 2, 3, 4, 5. I just highlighted 5. So how do we want to make the LED turn on and turn off? First, we must make sure the GPIO is an output. By default, all your microprocessors and microcontrollers, when they start up, that means after you press reset or you turn on power, they actually start up in input mode. All the GPIOs will always start up as input. Anybody know why they will always start up as input rather than output? Every market, when you start up, the GPIO, general purpose input output, must be an input. Okay, Sudam says safer. Why safer? So I can tell you, everyone starts up as an input. Okay. So you see, you use GPIO connect to other things. Okay, you can connect to LED. That's one thing. You can also connect to motor, right? So if you have started up in, say, an output mode, what is it going to be? Output high or output low? You see, you can connect your system in such a way that output low turns on the motor. You can also do it in another way is output high turns on the motor. So if you connect it, a microcontroller, you just start up and the GPIO become output automatically. There's no safe state because it depends on your implementation. It could have been output low or output high. Both of it you can use to turn on the motor. So that's dangerous. For all you know, the motor is controlling, let's say, your electric vehicle. Okay lah. Of course, your microcontroller won't be directly driving it so easily. But just say lah, you start up, it goes high, your motor starts running. That's your EV motor. No, right? You cannot. So that's why every single microcontroller on Earth, right? When they start up, the GPIO will always be an input. It will not be able to source, it will not be able to set it high or low. They will always be input first. That's the safe mode. So the first thing you need to do if you want to flash an LED is you need to make it an output. So that pin, you must make an output. How do we make it an output? Of course, in Arduino, you could have used a specific function. Now, those of you who did Arduino, what function did you do to set a pin as output? This one is pin 13. How do you write it? If you have used the Arduino library, you have probably written it this way, right? No, not set as output. You got something called pin mode. Then you set the pin 13, output. Correct or not? Those of you who do Arduino can remember. Pin mode, right? Okay, that says your output. Okay, you don't know, never mind. But those of you who know, that's a function that was built into the Arduino library framework. Okay, so good, you use the framework. What if you use a different microcontroller? What's the we cannot use Arduino, we have to use a different library. Sorry, we have to use a different microcontroller. What are you going to do? Sit and cry. Okay, you have to take the data sheet and see, okay, how am I going to do it now? So I showed you the data sheet already. I didn't explain in detail, but I can tell you now that if you set this bit, DDB5, if you set it to 1, it becomes an output. That means port B, pin 13, pin 5 will be an output. Port B, pin 5 is this. Port B, pin 5 is GPIO 13 on the Arduino Uno, which lights a LED. So Najmi said, in working, do we still use Arduino IDE or use bare metal C language? You use Arduino IDE, but you write in C without Arduino library. You use the IDE, but you don't use the library. Why I say use the IDE? Because a lot of people are familiar with the IDE. So just use the IDE. It has all the tools built in. It's easy to install. I don't use IDE, by the way. I don't use Arduino unless my customer tell me we need Arduino. Yes, then I use. Even when I use Arduino for my custom project, it's not like what you all use. Let me just show you an example of a project that we do for customer. We write in Arduino. We use IDE, but we don't use the library. So let me just show you. Just give me a second. Let me call out a project that I know that we did for our clients that was using the Arduino IDE. But that's about it. Okay. So I'm going to call out. You can see it's being launched on my machine already. Okay. So it's running the Arduino IDE. It targets Arduino compatible board as well. But it's not written how a normal Arduino is written. Right? What's updates? Okay, ladies and gentlemen, those of you that use Arduino, does this look like a normal Arduino code to you? I mean, does it look like normal Arduino? Or does it look much more like C? Very normal. Well, it's not using the libraries. Okay. I may use setup, I may use loop, but it's not using most of the libraries. Okay, I use all this, but a lot of other code is not running the library. Some of it, yes, but because this one is a customer code, that's why we do it. Because they ask us to do it, but half of it is not. Now I can show you another one. This one we did for the training last year. Okay, this one is we implemented a thing which is a temperature control and so on that we push it to it's an IoT system. Okay, it's an IoT based system. Let me show you. On that, I need to look for it. Okay, I'm just calling it up. I think Zoom is stressing my machine a lot for some reason. Doing a lot of processing, I believe. Okay, now, can you see this is Arduino? But if you look, okay, I do Bluetooth with it. I'm going to close most of this. You can see I got main function. It looks like C. It's written in C. You can take this code and go to other C compilers and you will compile. Yes, I use it in the Arduino IDE, but it's portable. And if you look, also another thing, have you realized there are a lot of source files? Well, most of you do everything in one source file, right? Anybody here has done projects in more than one source file? Anyone? Some of you may, but very few of you, right? Okay, good. Some of you, yes. But I don't think, based on my experience, 95% of you would have done it in multiple source files. Because when you learn C in a university, very few of you are taught how to deal with proper C programs. You're taught the basics of C, but you're not taught how a C program, a real world C program is like. Okay, so you can see this is like a real world C program will be like. So even the switch itself, we have okay, switch init. Okay, and various functions initialize the switch, right? Like string, this is not switch as UI, software UI. We are using a software to create a UI. Okay, I'm using the timer. I'm using the UART. So can you see? I got initialize the UART, write a byte, write a string, read a byte. All of these are not part of the library. We created our own library. When we create our own, we need to know how the underlying works. So the aim that I normally, when I do this embedded C course, my aim is not to use any libraries that are out there. My aim is to make sure you know how to build all this up layer by layer so that you understand the system and you can build on what you understand to build a complete system around it. So now you can see even my code is structured. I got GPIO to handle GPIOs. I got software UART, I got UART, I got timer, I got ADC, analog digital converter. So if I need a module, say I need an analog digital converter, I put it in. I've written the code a long time ago, so I tested and tested it's robust already, so I put it in. So somebody asks, how do you ensure your code is robust in edge cases when making libraries? Or robust to edge cases when making libraries? Basically, how is it robust? Okay. Show it to the expert. Basically, I'm the expert. Basically, we test every single one on its own first. That means, let's say I write the ADC library. I'm just going to test that alone, I'm not going to test it with other things. Maybe I may need a GPI work, but I just test one at a time, make sure it works. And of course, like what you say, you have to work on test cases. And other things that you may realize is there's a lot of debugging also involved. There's a lot of error checking involved. And you see something like this here. For example, if channel more than max channels, return error. That is something very important. When you call a function and you're going to send parameters to the function, make sure they are all valid. So you have to write your when we write our libraries, we make sure that it's very robust. The error handling mechanism comes in early on, not say, oh, finish already, then because got a bug and do checking. No, from the start we deal with the errors already. That's why if you look at the header file that I do, can you see I define success, error, init, error channel, error timeout. So whenever I call a function, it will always return an error code. It could be success, but it could be error as well. So this way, even though it's a small function like this, it's a small file like this, but when you have the error mechanism all built in, you can quite easily detect the errors as you are building them. That is a key, we don't build everything already, and then after that, press compile, yeah, compile, fine. Put load, cannot run. Then you start scratching your head. Why? Why cannot run? You may have written 1,000 lines. It doesn't run. No. When I build my embedded system, especially by starting a new, let's say using a new microcontroller, I start with the most simple, flash and LED. Yeah, I got 25 years experience in this. Yes, I still flash and LED. Because, yeah, you say, flash LED. Yes, if you flash and if your LED can flash, it means your hardware is working. Your oscillator is working. Because you see, we create our own hardware. So sometimes, okay, say Arduino. Arduino board works fine. Well, you take the Arduino and put it somewhere else. We implement it, we shrink it down to very small. We need to make sure our hardware works. What better way than to do so? Flash and LED. Okay, so that's why I start with flash LED. Because if you can flash an LED, it means things are, at least some things are working. So someone said, build auto checker to monitor where there are errors. You build it with error detection in from the start. Error detection is built in from the start, not as an afterthought. Okay, not as an afterthought. So you can see this simple library here. What auto checker? I don't know what auto checker you're talking about. You are talking about code checker. Code checker, your compiler can handle. Runtime check is something that your code must handle. So static checking, compiler handles most of it. Runtime, you have to handle. So how to check? Well, that's a very big question. Okay, I mean, to start off with, error checking like this. You have to build in the error checking mechanism from a start. So like, for example, I give you some other example like UART. You see, UART read byte, for example. If the buffer is empty, I said buffer empty, nothing to read. Or else, I do what I need to do and I return success or fail. Okay, so that's how we can start it. So basically, when I teach people about the system, the error detection comes in at a very early stage. Okay. Now, let us get back to this. So we know to flash an LED, we first have to set port B, pin 5 as an output. Only pin 5, only pin 5 we have to set as output. And this register, DDRB, is at a specific memory location, which is 0x24. Note that, is at a location 0x24. Don't care about the 0x04. Look at 0x24. So you know that what we know that we need to do this. Okay, hold on. Okay, we know we need to do this. Set bit 5 of DDRB high. Set means set high, okay? Set DDRB to 1. Set high. Okay. How are we going to achieve this? Now, DDRB is at location 0x24. So far, so good. This one comes from the data sheet. Okay? That's what the data sheet says. You buy this processor, it says that DDRB is x24. You have to use that location. You can use other location. It's not DDRB anymore. Now come another question. Okay, don't worry about 0x04 because they have two different addressing modes. Just concentrate on 0x24. Okay, look at the one in bracket only. I don't want to go into detail. Okay, that one during training can, but not now. Too short a time. But now I got one important question is how to write a value. So that's a very specific question. So somebody asked, use Claude. You can use whatever you want. If you plan to learn, you don't use whatever you want. You just use this. If you don't want to learn, you can use whatever you learn. Okay? There's a difference. I know you are the what I call the double whammy. First, a lot of you started your degree during COVID. Secondly, by the time you finish, AI come out. So during COVID, fundamentals may be lost. AI come out, fundamentals are lost. Double whammy. But if you really want to learn, don't start with AI first. Okay, learn from the basics. There's not many basics, not that hard to learn the basics. After you get the basics, like for me, I use AI every day also, even to write code and all this. But the difference is, okay, especially when early days is, I know when the code is wrong or right. I just use AI to help me so it's faster. I'm more or less, even if code I never see before, 95% I would know whether it's correct or wrong. I never done Android programming before, but last 2 years ago I started. Okay, I will know because there are concepts that are very related. So I know when I just use ChatGPT, I don't even bother with Claude or whatever. I use it. I know it's talking rubbish or not talking rubbish. Okay. Even with a new program, 95% I'm sure whether is it talking rubbish or being sensible. Of course, it has improved a lot. Now, as I said, when we run all these programs in training in the past, they use ChatGPT and all this. So you go ahead and do. At the end of the day, when I give you an assessment, it's on written paper. You are not going to have your computer with you. I will know whether you know the fundamentals or not. The fundamentals, when you know, with or without ChatGPT or whatever, you know the fundamentals, you can port your knowledge across. You do not know the fundamentals, you can have all the AI in the world. The lacking is you don't fully understand what is being done. That's a key difference. Okay, so a lot of you are in the generation what I call the double whammy, whereby you started off during COVID times, and at the end of the day, you use AI. Like a lot of what the others have been saying, the speakers have been saying, the fundamental is still important. You cannot run away from it. What makes the difference between somebody who can be engineer and somebody who's super engineer? Fundamentals. And if you look around my lab just now, you can see so many things here, right? I need the fundamentals that have to be applied to physics and everything else, not only engineering. Don't only concentrate on engineering alone. Like it's data system and you're doing application side, it's all around. I have to speak to a lot of doctors, like especially projects that you do at WH and all this. You have to understand fundamentals that are not even engineering, medical. Okay, so we have done many projects. I even had to understand some of the fundamentals of farming and aquaculture. What fundamentals is a must? You know physics, you can apply to all. If your physics is strong, it applies to chemistry, because if you're got good physics, you understand chemistry as well. Chemistry is applied physics, and biology is applied chemistry. Okay. Now you don't need to be a super mathematician. You need to have good maths, reasonably good maths, can understand matrices a bit here and there. Okay, but it's not until you need like until you're Terence Tao or somebody who's super good at maths. That's why no engineers are. But you should know some, like, apart from operation and so on, matrices and so on, so that, because a lot of computation is done that way. Okay. So somebody asks, have you ever dealt with parts or products that do not have accurate data sheets? Anytime you touch anything from China and so on, assume one thing: the data sheet is not accurate. Simple as that. Okay. Yes, we do very often. Normally, companies like Texas Instruments and all these, their data sheet is very accurate. China company, sometimes the product doesn't even match the data sheet at all. Okay, so good luck. Now, anyway, back to this one. Sorry, digress a bit. So I did ask, what do you write a value director for? And I think somebody mentioned something. Leong Kim Fu mentioned pointers. That's the only way. Okay. Now I know a majority of you will probably say, I hate pointers, or I don't like pointers, right? Anybody here that say, I like pointers? Nobody there to say. Okay, but I can tell you one thing, without pointers, you cannot do it at all. Because a pointer is the only construct that you can go to any specific memory location. In C or any other languages, what other way you can go to a specific memory location? You can only go through it using a pointer. So how to write a value to a specific location? You must declare a pointer. Okay, so let us go back to our code. Now, switch to your Arduino. You can see on the left there, we got our code. So now, I'm not going to use Arduino anymore. In main void. Okay. That is going to be the start of our code. Now, it's a bit smaller. Let me see whether I can enlarge it a bit. Oh, enlarge it the other side. Never mind, zoom out the other side. Ladies and gentlemen, I hope you all can see the code. Okay. So, don't like pointers? Sorry. If I'm going to teach you from the fundamental initially, I have to show you a pointer. No choice. Because as I say, you can only do it using a pointer. So I'm going to declare a pointer. I'm going to declare an 8-bit pointer. But first, I'll say hash include std_id.h, standard integer. Okay, so uint star. That's a pointer. PTR, that's the name of pointer. Okay, now how do I run that location? This is how I'm going to do it. PTR equals to 0x24. Okay, PTR equals to 0x24. Fine. I declare a pointer, line 4. Okay. Okay. And now I want to say bit 5, set it to a 1. That means port B pin 5 will be an output. So I will do it this way. Dereference PTR equals to now I need this bit, only this bit to go to a 1. Of course, you have to, there's only one correct way of doing it, but never mind. I show you a simpler way first. This is not the correct way. This is not proper. It will work only in these circumstances. Okay, I make a note there. That's not proper, but will work for now. Okay, so line 7, I've just set the value of 0x20 to location 0x24. What I'm doing, I'm saying DDRD equals to what? Okay. Ben Lam said, can use 0B? Sorry, C doesn't accept binary. Okay, so you have to write in, I write in hexadecimal, 0x20. You're not doing Verilog, unfortunately. Okay, so now we have set DDRB. Okay, so we have set the output, but we still need to do one more thing. If you want to turn on the LED, you have to set the port pin 5 to be 1. Okay, so how do we do so? Anybody? How do we do so? We want to do this. So we have set to do this. Let me call out. Okay, that's one thing done. How to write? How to set bit 5 of port B to 1. If you do that, the LED will turn on. How do we do it? You all can put in the chat. If you can do it, or if you roughly know how to do it, please write it in the chat. Anyone? Write it in C. Yeah, just say that way. I think we simplify it first, okay? You are, that way is pretty advanced. You know what you're doing. I think a lot of people wouldn't understand what you're saying. How do we do it in C? Like Chong also mentioned. Sudam, why all those things come out? Are you using ChatGPT or whatever? It's giving rubbish. So far, Jack's answer is correct, but it also means that a lot of people wouldn't fully understand. Okay, now I'll make it simple first so that most can understand. No, we don't want digital, right? Now, PTR equals to 0x. Now, what is port B? Port B address is what? 0x25. Okay, 0x25. Okay, so that's port B. And then what do? The reference a pointer. When we put star in front of pointer, we are saying at that location, do what? Okay. So Akmal said, okay, can. But when you want to introduce DDRB or DDR or port B, you actually have to include another header file, the Arduino header file. That will have defined what DDRB and port B is. But this method that I'm showing you on the board is generic. Any compiler would run it, would compile it. Okay. Now, ladies and gentlemen, you have written this already. You can give it a try. Now, observe the LED L. Observe the LED. Click on start the simulation first. Okay, so those of you who are unpaid, you have to wait. View server load seems to be very high. It will take a while. But if everything is running correct, when everything is done, when it runs, you should see the LED being lit, LED L being lit. Okay, it could take a while. Free plan, so it's unpaid plan. If it's paid plan, then we much faster. Now I'm doing it like this with you. Of course, I got the board and all this with me. I can have done it in front. But the point is I want to do it together with you so that all of you can see it as well. Oh, it's taking a long time. Just now build server load was halfway and it took about 20 seconds. Okay, those of you are done already. You should see when your code runs, the LED turns on. If you have done so already, you may want to modify it slightly. Then you can let it turn on and turn off, blink. Okay. So Sanjeev asks, with those inaccurate data sheet, do you throw away the product or work backwards? Well, normally we get back to the manufacturer and say we got this problem and that problem, why is it so? It depends on how expensive product is. Normally from China, and then we purchase a complete product, so we get back to them that we don't buy ICs from China. Okay. Now, it's not only China or what. Okay. It's sometimes even the big players also, they may have errors in the data sheet, especially when it's the first generation. So if that's the situation, we ask them, can you give me something? Oops, they don't even want to run. There, the LED turns on. Okay, so all of you should get this. Chin Hao Yik asks, does RTOS work with Arduino? RTOS is just a real-time operating system. That's all it means. It can be a very simple real RTOS. RTOS can be also very complicated. Simple RTOS can run off Arduino, no issue. Okay, but the functionality will be just maybe basic scheduling and so on. So Ramalakshmi said, star PTR equals to 0x20. We don't actually instruct to fetch address from location that. We are actually saying at location pointed by PTR, put the value of 0x20. So that's why you see line 6 is needed before line 7. Line 9 is needed before line 10. So line 6 sets it to point to a location. Line 7 says at that location, PTR is pointing to, put the value of 0x20. Okay, so line 7 and line 10 is like what Chia Jinghao says, we are dereferencing the pointer. So we say where the pointer is pointing to, those values see. Now, let me ask you, ladies and gentlemen, this code here, does it use any libraries? None at all, right? Can you control everything on the processor using pointers? Can you read and write to any special function register? Yes, you can. Anyone. This is fundamental code. If you know how to do this, any processor you can handle, with or without libraries, you can handle. Okay? I know you have been using libraries, so a lot of these have been hidden from you all. But I just show you, it's actually not that difficult. One pointer is all you need, actually. Okay? None at all. So if you know this, you take any data sheet, you understand the data sheet, you can actually write your library to handle anything. So this is something which I consider very fundamental. Yes, we normally don't write at this level anymore. Okay, we encapsulate the pointer and so on. But if you understand this concept, you can control any microcontroller. Any questions, ladies and gentlemen? Why the value 0x20 or 32 is written? That comes from the data sheet. Okay, for this particular hardware, the data sheet for the hardware says that if you want to turn on port B pin 5, you have to write it to that location. It comes from the data sheet itself. So Arif say, is this also work for MCU side? The pointers work for every single processor out there. So if you don't have a library, as long as you know how to use pointers, you can control it. But of course, you need the data sheet to say where to write and what to write to. But once you know where to write to and what to write to, this is how to write to. Settle. Everything settled. Sanjeev say, given a running system that cannot stop on operations, will you forgo cache errors? No, you have to cache errors. But if you got certain errors have to be classified, like maybe a warning, maybe severe, maybe fatal. Each one of them you have to handle differently. So like, for example, if you are dealing with a car system, if you get a fatal error, you're not going to stop. You have to go into safe mode straight away. Oh, okay, yeah, 0x20 is hexadecimal. When you convert to binary, like what Chia Jinghao said, is 0010 0000. Okay. Unlike Verilog that accepts the B notation for binary, in C they only accept either decimal, octal, or hexadecimal. Binary is not accepted. Okay. Anybody else got any questions so far? Encapsulated pointers. At the end of the day, you use a lot of pointers, but you don't see it because it has been hidden from you. So that is probably that's a general term of encapsulation. For example, those of you who do object-oriented programming, and you want to refer to a specific object itself, you either use me or this. Right? If you are using in C++, you call it this. So this refers to the object itself, but actually it's a pointer. So it has to be encapsulated. You just say, oh, this dash what, do what. But this is actually a pointer. So it encapsulated from you, so you don't see it. Can we use Rust to write embedded systems? You can use a lot of languages to write embedded systems, including like Python and so on, as long as it is able to generate you the code that runs off it. Okay, so C, C++, definitely, assembly, definitely. Python can, as long as you can convert it into equivalent of that assembly. Now, some embedded systems actually run an OS. Like, for example, we have embedded systems that are embedded Linux. Like, for example, a good example of embedded Linux, your flight entertainment system, they're all running embedded Linux. Okay? Yeah, you can change it. You can use what Python and all this on it, no issue. Volatile, I know you saw in the code there, I got volatile. It is a specific keyword in C, just to tell it, don't optimize out that one. This one is quite detailed, and only during the training I will mention about it. So now, back to the code. Now, you all can turn on the LED already. So let us take a step further. And now let us do a flashing LED. Okay. Okay, just to make sure things work, let's do a flashing LED. Now, later, before the end of today, I'm going to make it such a way that you have this basic library. Okay. Okay, now let us make flashing. So I think I use 50,000. I think I'm going to use that again. So you in 32T DLY. DLY stands just a variable for delay. Okay, simplest possible way to create delay. First of all, we want the LED to continue flashing, so you can have a forever loop here. So you do something like this, that means all of these in the loop will run forever. Okay. So, sorry. So that turns on. Okay, so I put a note here. Turn on LED. After you turn on LED, let's give a delay. Easiest way for DLY equals to 0, DLY less than 50,000, DLY plus plus, okay? So that will cause a delay. Now, it's actually good to use the keyword volatile here. Because sometimes when you do optimization, right, the compiler says, hey, hang on a second, line 14 doing nothing. Kick it out. When you do optimization, the optimizer will see this one got any meaning or not, doing anything or not, kick it out. Then your delay will be lost. So to prevent that, I will use a keyword volatile or variable declaration, DLY declaration. Okay, so this one causes a small delay. How to turn off the LED? Can you put in chat? How do I want to turn the LED off? Anyone? Okay. So since I'm going to point to the LED all the time, I actually can take this part out first. I can put it here. So point this one. Okay, this is actually this is the one that turns on. So what I'm going to do here is this one I want to point to where? Point to 0x25, which is port B. Now that's a delay. So now I want to turn it off. Okay. So star PTR equals 0x00. Turn it off. Okay. And then I do the delay again. Okay, Pang, let's make it simple first for now. Don't go so deep. Some of your friends have never touched Arduino before. Some of the participants have never touched Arduino before. Okay, so ladies and gentlemen, get to this, run your simulation, or should I say recompile and see whether your LED starts flashing or not. Okay, if you get an error, please check where the error is. You can see the code here. So I got two delays. Line 13 and line 15, that's the delay. Line 12 turns on, line 14 turns off the LED. Okay, it'll take a while to compile, server load is so high. In the meantime, if you got any questions while waiting for this to run, any questions, just go ahead, shoot. Takes a long time to compile, huh? Well, Chia Jinghao say yes, it becomes that because you actually did an XOR. One user say, is coding a general term for programming? Well, coding is basically you write the code. Programming is to develop the whole system. Nasri said, is it faster with VS Code? Faster in what sense? Compiling the code or creating the code that will run faster? Okay, Lucas, yeah, new to it. You come for the training, then you'll be much more detailed. I cannot go into too detail, or else I can't finish. So, Chin, what is the difference between PTR and star PTR? PTR sets where the pointer is going to. Star PTR is to use or to write or read the location that PTR points to. Arif said, what is the for? That is a loop, and it means loop forever. Now, in an embedded system, it's not like your desktop software that when you finish, you go back to the operating system. If your embedded system has no OS, it doesn't stop. Once you turn on, it runs. Turn off, it goes off. It doesn't stop. If you got no operating system on your embedded system. When I mean no operating system means like no Linux or what. FreeRTOS, which is an operating system, that's not it. Because FreeRTOS doesn't have something to fall back on. So, ladies and gentlemen, if you have gotten it correctly, you should see the LED blinking. Okay. Akmal said, not a void loop, is a forever loop. User, is there any other simulator easier than Arduino for learning? Oh, I don't think so. I think it's a very, very easy simulator already. Okay, easy also means it's also relative. What's easy to me may not be easy to you. So my answer to you is I don't think there's any simpler one, but there may be others that you are more comfortable with, or maybe they come with slightly different approach that you understand better. So for me, this one is what I consider maybe the simplest or the easiest. Chan said, what's easier to use, Arduino Uno or ESP32? Well, depending on how you want to use it. If you want to use it at this level that I'm showing you, both are practically the same. Of course, the ESP32 has a lot more involved because it has Wi-Fi built in, so the data sheet is a lot longer. So in a sense that, in a way, it could be harder to use, but if you want to use a flash LED, it could be about the same. All depending on what you want to use it for, how you want to use it. Why need to point to 0x24 first? Okay, because that sets it as an output. Okay, 0x24 is DDR-B. That is to set the IO pin as an output. Can I learn using STM32? You can learn using most of the microcontrollers out there. They are all, once you know one, all of them work roughly the same way. What's different is how they configure the peripherals and all this will be different, but generally speaking, they work the same way. What are key datasheet parameters to include to know which MCU is suitable? Oh, big question. Normally it's like this. When we know a certain family well already, we stick to it. Okay. For this one, it's not a for loop, it's a forever loop. It just loops non-stop. There's no terminating condition to this loop. Okay. So this one, put a note, there's a forever loop. We call it a forever loop, not a void loop. The loop doesn't terminate. Okay, ladies and gentlemen, you all get your anybody got problems getting the LED flashing? And all of you managed to get to hear? Wait, oh, I forgot to scroll down for a short while. Sorry about that. So let me just check what you have asked. Ben Lam said, does embedded system have anything to do with kernel system programming? In a embedded system like this, there's no kernel because there's no OS. Basically, you're writing it, the kernel. Okay. Is PLC a microprocessor or something else? Most PLCs nowadays are actually microcontrollers built in. Okay. The heart of it is a microcontroller. It could still be a microprocessor. Okay. Yes, a lot of you are compiling at the same time, so your server load will be high. Okay. Don't worry about the flashing speed. Don't worry about that. As long as it's flashing. Okay. Don't worry when it comes to the training, actual training, because we'll be using your own computer. And we won't use we'll use the real hardware. Okay. Don't worry about that. This one is so that all of you can try out. Now, never mind if you are still compiling. So you can see here, the code we have written is practically the simplest flash LED code. Doesn't require any library at all. If this one works, good, you know it's running. Amal said, how about Raspberry? Can I still be using this register language? No, this is not register language, is C. We are using C. This is bare metal C. That means not running off any OS. Okay. Jing Hao said, what is the unit of 550,000? It's just 50,000 times going through the loop on line 13 and line 15. How the for loop, if it is like that, becomes 10 assembly instructions, and each one take 1 clock cycle, then it will be 10 clock cycles per loop. Okay. So there's no, currently, this particular one, we are not using any timers or what. So it's just the number of instructions that's going through looping 50,000 times. How long it takes, I'm not sure. But if you look at my previous code, I show you this one. Okay, so you see my screen, this previous one. Now, when I'm using a hardware timer, I'm able to very specifically say how long it takes, because I got a global variable here called systig. Now, systig would increment every single time, or will increment once every millisecond. So systig is counting the number of milliseconds since I started, because I'm using a hardware timer here. Okay, so in our very simple code, I'm not using any timers. I'm just looping 50,000 times there. Hold on. It doesn't depend on any script. Remember, it's compiled. The C program is compiled to assembly language. It depends on how many assembly instructions generated in one for loop. So if let's say 10 instructions generated per for loop, then if you got 50,000, it actually goes through 500,000 instructions. See what it says is this pointer concept used in saving data to non-volatile RAM. Well, can be, depends on the setup of your system. The timer, is there anything to do with the crystal oscillator hardware? Yes. The timer is typically triggered by the crystal oscillator. So the timer can be set in such a way that because the timer is actually clocked by the crystal oscillator. If you say, for example, in this case, if you got 16 megahertz crystal, or 20 megahertz crystal, and you divide it by 20 million times, then the timer can be incremented once a second, for example. Okay, so the timer is actually clocked or incremented by the crystal oscillator. So it's very precise. It's as precise as how accurate your crystal oscillator is. Okay, finish. Can I continue? Anybody still got problem or what? Build server busy, still busy. Oh, pay money. Oh. Jason said, how to ensure 1 millisecond in hardware is the same as 1 millisecond real time? The timers work in very specific manner. If your crystal oscillator is accurate and your timer is set up correctly, it'll be very accurate. Most crystal oscillators, accuracy by default is about 20 parts per million. So if you got 1 mega crystal, you'll be out by, it'll be like 999,990 to 100,010. That's the range, okay? Or 0 to 0. So basically, a lot of crystals that you buy off the shelf, they are 20 ppm accurate, 20 parts per million accuracy. You can get more precise ones. Like for example, you saw I got oscilloscopes and all this around me. They need more precise crystals. So they probably have maybe 5 ppm accurate, 5 parts per million error. Of course, the crystal costs a lot more. I've used before crystal that is 1 ppm, 1 part per million error. Compared to 20 part per million error, 1 part per million error could be 100 times more expensive. Okay, but it's very precise. So if you need the precision, like for example, you're measuring very accurate, you need very accurate measurement, like for oscilloscopes and so on, you need to pay for it. Sia asks why my OX20 is blue in color, but yours. That's a good question. I'm not sure because I can't see your screen. Okay. Oh, I'm in dark mode, so it looks at okay. Okay. I know what you mean. Why mine is green and yours is blue, but I do not know dark or light mode. Oh, okay. I see now. Okay. I normally use dark mode. Okay. Can I proceed? Now, those of you cannot compile anytime, you still can proceed with me. Okay, so you see now we got a basic code that's running. I hope all of you going to get our code is running already, but not so nice, right? Because you see you're writing in this way and so on. So let's start doing some encapsulation. Now, this is where it gets more interesting because we are going to create more files, each one to handle specific part. So let's say this one is for the LED. So I'm going to create 2 files. I'll create the main file first for the LED. For this one, what we need to do is we need to create a new file. You click on this down button, new file. I'm going to call it LED.c. As I say, most of you never do multiple files before, right? So welcome. First time doing. Okay. Next thing, very simple. Let's start with a Control A to copy all, to select all, Control C to copy. Go to led.c, paste it there first. Now, I'm going to do this. Okay. Oh, sorry. Still include std_in.h. Now, we are going to create LED init. Okay. LED init, I've written a void. Hold on. I can say sudden zoom on my machine heats up my machine like crazy. It's like using a lot of my bandwidth for some reason. My processing bandwidth. That's why I also slow down a bit on my machine. Okay. Void means not returning any value. LED init. Now, how do we initialize the LED? Okay, I'm going to copy and paste this one again because the next one I'm also going to use it. So I've stored it first. So LED init, you have to declare a pointer, and we want to set it. Okay, this one. So this part will be LED init. Okay, so it initializes the LED as an output. Now, the next function I want, okay, now I'm going to copy and paste again this one because it just makes things a bit faster. Now, LED on. Okay, LED on. So how do we turn on the LED? LED on, we need to use PTR equals to 0 to 5. And then to turn on LED is this. Okay. So I got LED init and LED on. So you can see the code for it. Now, ladies and gentlemen, please write the code for LED_off. LED off. I'll let you do that. Have some fun. Okay. LED off. How do you write it? Akmal asks, can C# replace C or C++? Cannot. C# doesn't have some of the constructs that you use in C or C++. Okay, that's why you never see C# used for embedded systems. It doesn't have all the constructs needed. C# is meant for higher level, not for this level. So, ladies and gentlemen, I changed it already. Now you can see. Now I got function LED init, LED on, LED off. Muhammad Ibrahim, why you want to put the delay inside here? Don't put it now. Now you just concentrate. You turn on LED, just turn on. You turn off, just turn off. You initialize, you just initialize. So we are trying to create basically a small tiny library now to handle your LEDs. Okay, and not complete yet, because we have created a different file with these three functions. For your main file to use them, we will normally create something called a header file. Okay, so I'm going to create another file, and this one I'll call led.h. Okay, now what do we need to put in a header file? The header file actually needs the names of the functions that you want other files to use. For this one, because the C The Arduino compiler is actually a C++ compiler, and we are writing in C. We have to do this one first, extern C. Okay, and then in there, we say, okay, void LED void. Okay, but we have to use the keyword extern. When we use the keyword extern, we are telling the compiler that LED init is external to this, is somewhere in the project, but not in this file. LED on and LED off as well. So this is what we call the header file. You want to see my .c file again, right? Okay, that's the .c first. Now, let me copy the .h. This is going to be .h file. I copied it. You can see the C file. And I'll put my .h file here so they can see it side by side. Okay. Okay, that's my .h file. Ladies and gentlemen, any questions? Lim asks, does the concept of state machine is it very common in embedded systems? Yes, very. Okay, later I can show you. Very. Pakeha asks, in the sketch INO part, is it blank? No, it's not going to be blank. We are going to modify it, but first, the LED.c and LED.h must be like this first. We are going to modify sketch. Snow said, extern C is for what? When you use a C++ compiler and you want to compile a C file, you use extern.c so that it knows how to compile it suitable for C. Okay. Now, Arduino compiler is actually C++. Mohammad Irfan said, why does LED turn on longer than off? No, it should be the same. We are running under simulation, so it may look different, but in real hardware, it will be exactly the same. The simulator is just simulating only. The clock cycles are not very precise one. It's not like true hardware. And ask, can I see the code of LED.h again? Is there? The code for LED.h is this. I'm highlighting it now. Okay. Oh, now it's going very fast. If extern C not included, it still works the same? Probably not, because the compiler compiles it differently. Okay, so you should add it in. What's the difference between C and H file? Okay, that's a very good question. C and H. C is to hold your code. H or header file is to let other files know what your this C file, what functions and variables that the C file can show. Okay, if those of you are coming from, have done object-oriented programming, you know, when you deal with classes, okay, you can create private, protected, or public members and methods, right? So likewise in C, when you create a file, .c file, the .h, if you want a function to be available for others to use, you put in a .h file. If you don't want, don't put it there. So it's a bit like in using classes that are members or properties that are protected or should I say not protected, public or private. Okay, hope that answers your question. So whatever you're not expert or available to others, like LED in it, LED on, LED off, you want all those other source files can use, you put in the header file. Okay, those of you are not done, can you please take a snapshot of the screen, because I want to show you how we are going to modify the sketch.ino file. Another question came in. LED.h is like call coding from what file? No, I'm going to show you how LED.h is going to be used. I'm going to show you shortly. Okay, it's going to be used in the sketch.ino. Okay, ladies and gentlemen, please take a snapshot, screen capture or what. I'm going to switch away. I need to show sketch.ino already. Okay, let me switch over. So very good question. Until now, we have declared LED.c, LED.h, but we have not used it. Go to sketch.ino. So now we don't need to declare any pointers because these two now is handled by what? LED init, right? And then turn on LED. LED on. Turn off LED. LED off. So now you can see it looks a lot cleaner. But there is just one more thing. The header file must be included, or else you cannot use LED init. You can see, I'm going to compile first. I show you, I'm going to compile now. Okay. I'm going to compile now, and you will see that you get an error because it says, okay, it may take a while to compile, free version. Build server load maximum. Okay. Okay, ladies and gentlemen, please include it. Since the build server load takes so long, I want to show it to you, but since it takes so long, you include LED.h. Now, the LED.h that I include here, you see it's no longer in the angle brackets, Now it's in double quotes. There's a difference. When you use angle brackets, it means it tells a compiler stdint.h is a header file that comes with a compiler. When we put hash include led.h in inverted comma, is telling the compiler led.h is our own header file. Look in the current folder. Hazik asks, can this coding run on Tinkercad? I don't know. I don't use Tinkercad. My apologies. I can't answer that question. I use the Arduino IDE or I use the ARM QMDK. This is my compiler. I'm going to run it now. Show you shortly once it's up. Now I've not finished compiling the project. You see, it's still compiling. So let me show you another thing first. Yeah, and as I said, for some reason, Zoom really heats up my machine. My fan is running like crazy. Oh, so somebody mentioned, nope, someone tried Tinkercad already. Doesn't run. Okay. Oh, before my compiler runs, now you can see build fail. Why? LED init not declared. LED on not declared, off not declared. Just now when I start the compilation, I have not added line 2. Now I've added line 2. I recompile it. So you can see now I added line 2, the header file, led.h. Now I'm recompiling. Sorry, I had to wait many seconds again, but now it should work. So the header file that's a use. It acts like an interface. It specifies the interface for LED.c. Now, the header file, LED.h, doesn't need. Okay, the header file for LED.c doesn't need to be called LED.h. But let's not shoot yourself in the foot. So let's say if your module is called LED.C, best is the header file also called LED.H. That's right. Can this concept be used to implement NMEA prayer code for GPS systems? This is a concept of programming, can be used for anything. Not only C programs, Verilog as well, and so on. It's all these are concepts. This concept is what we call modularization, making multiple modules from your code so that you can reuse and it's easy to debug and so on. Which explanation? Tan is asking. Could you say the explanation earlier again? Which one? About what? Header files? Okay. So you can see that the header file, okay, I explain again. The header file acts as the interface. It tells other code what it can be done. Okay, close. Server busy. Is it running? Yeah, it's blinking on mine. It's not blinking very accurately, but it's blinking on mine. It's running on mine. So you got LED.C here, and you want only some or others, you specify the header file. Give you an example. Which is not very if I give you an example. Okay, Chia Jinghao gave a link to W3 school. Yeah, we can learn C from there. But that's you learning C, not learning concepts. That's the difference. We teach concepts. C is used as a tool. The concepts we teach you can be applied to any others or most other languages. Yeah, LED init is changes input to output. So when using hash include LED, it's like using self-custom library. The LED.h file needs to be kept open. Well, you create the LED.h file is like an interface file. It tells you when you include it, you know what you can use. That means the code that you include into can use those things. I'll give you an example here. Now I switch back to LED.c. You know we got init, on and off. Let's say we got one more. Let's say we got void LED, say toggle. Okay. Now I'm not going to do anything in this code. I'm just going to write toggle. The thing is, if you don't, in LED.h, if you got no LED toggle, you cannot use, Okay, let me show you what. So now in LED.c, I got one more function, LED toggle. Okay, I didn't put anything in the function. Okay. In sketch.ino, let's say I want to run LED toggle. In C, case is sensitive. So you have to be very careful about the case. Now, I did not in LED.c has LED toggle, but I didn't put it in header file. So if you look at the header file, my machine is really hot. Hope the 600 furnace are running off my machine. Okay, so you can see I don't have LED toggle here. So in my sketch, I call it. Now, let me compile it. Okay. Okay, it will take a while again, but it's going to come out an error. It said cannot find LED toggle. So the header file is a controller. Any source we can learn programming concepts. Well, that's a very good question, because by the time I know most of my programming concepts, the internet just came about. So basically, my programming concepts are all learned as I go along. I didn't actually read from any book or learn it online. It's through a lot of experience. As I say, I've known how to program since I was about 8 years old, and that was 40 years ago. Okay, so yes, there are a lot of the concepts is the harder one to teach. The language is one thing, but the concepts come for me. It came from experience. How best to write this, how best to write that. Even layering the code. All this came from experience. I didn't actually take any training. I do training. The last time I took any training was like 20 years ago. Okay, and it's not in C or whatever. It's just based on my experience. That's why I mentioned to you that for me, is a lot of it is based on experience over 40 years of programming. So that question you asked me, I still not know how to answer. I and I'm going to go back to saying that nowadays, as mentioned, what concepts are being used, and sometimes they recommend doing certain things certain ways. So those are good practices as well. Would assembly in bare metal programming be more intensive in memory handling with registers and such? Well, you can still do bare metal. Oh, he didn't complain, right? You see? Okay, in a real C program, it will probably say, hang on, LED toggle is not there. It should cause an error. But I put it here, it doesn't cause an error. There's something, the compiler says, I found it, I will give it to you. Okay. Now, the C compilers, the C compilers have evolved a lot. Nowadays, they do a lot of things. They assume this, assume that for you. But if you want to be strict, putting LED toggle should not actually, and not in the header file, should have actually caused it to cause an error. It should have caused an error. Well, assembly would be lower level still, so you have to do your own memory management assembly. You cannot just create a variable like that and assume that you're not using it, it goes away and so on. Now, ladies and gentlemen, managed to get to this stage so far so that at least you have some sort of like a basic idea. Any big problems? Any questions from anyone? If LED protocol has any function, then can't be because not included header. By right, yes, actually, Arif. But this compiler I'm not familiar with. It seems like either it remove LED toggle because there's nothing in it, or it compile it. Okay, Lim Zinyi is showing something. Let me have a look. Hold on. LED toggle wasn't declared. Yeah, that should be the way. Okay, because you didn't declare it. Pang Winjan, why do we not need to include LED.c file? you never include the C file. You include the header file. All the C files will be compiled. All the C files within the project will be compiled. Okay, the header files are the ones that allow a particular C file to see or not see other C files. So the header file is like controller, the gatekeeper. Okay, all the C files within the same project. That's how the compiler normally works. It's not always the case, but generally that's how this compiler said. Why not anchor bracket? Why use the codes? I did mention if the header file is your own header file, you use the double inverted quotes. If it's coming from the C compiler, you use the angle brackets. So stdint.h comes from the C compiler. That's why you use the angle brackets. Okay. Now, so just now some of you, okay, I'm calling out quite a reasonably complex real world code. And this one is probably about 20,000 lines. Okay, not very big, but for embedded is quite significant. So you can see here, we do a lot of checking now. This is my main routine. And one of you asked, do we use states? Yes, we do. A lot of times we build things as a state machine. So you can see this is my main code. Okay, my main code. Then I initialize the system. After I initialize everything, I go to my forever loop. In this forever loop, I got my main state machine. So it's case init, sysmod init, do what, do what, do what, do what. And you can see also some other aspects of it. I do sys init, okay. Sys init here, initialize the system. I return an error code. I check whether is it successful or not. If it's not successful, fatal error. And I go to a fatal error handler. Now, this one automatically means I jump to a particular location to handle the error. What I want to do, it depends. For this kind of program, we just read it. Okay? What else I do is initialize. Okay, this debug print is my function. So let's say when I start doing the program, I need to do a lot of debug. Yeah, I know it's a bit laggy. I realize more or less when it gets laggy, when the fan on my computer goes super fast. Okay, now this debug print is if I want to send my code, the code to my client, let's say it's finished code, I don't need to print all this. Okay, I don't need to print all this. I can go to one location in my program, which in my case here is either global.h. Okay, I set this one to 0. Just that one single bit in the entire project of so many files. I set that to 0 and all my debug prints will not be compiled. All of them. Okay, so I know these are the ways that we do, because in your case, most of the time, if let's say you got debug information and after that you don't want to show debug information, what you do? You do this. You do this, right? You remark it out, right? My whole project here, I probably have 200-300 debug prints. 200-300. Okay? I don't do it that way. I go to one header file that I specify, debug print enable, 0. Recompile, that's it. No more debug prints. It's still in my code, but it's not going to be printed because we do something like this. This part is oops, sorry. This is something what we call conditional compilation. Okay, conditional compilation. So the compiler will either compile this bit or this bit, all depending on whether debug print enables 1 or 0. So if I set it to 0, all my debug prints become nothing, no code at all there. I don't change anything in my main code. I just change one part and recompile. It takes 2 minutes to recompile, and all my entire project has no debug print. Okay, set it on. 2 minutes later, settle, all print out. Well, this is not about speeding up the loop or what. This is about showing you that debug real life application, if you know how to do it properly, it's all the code is there. You don't do remarks here and there and so on. So your production and your debug code is the same code. It's just the setting that you set only at one single location, compile, and that's it. Saves you a lot of time, saves you a lot of headache. So these are the things that I teach people how to do so that your production will be much better. And I also when I start, I'm very slow, because you have to build up the foundation. But as you build up, as you go along, then you realize that once your foundation, all the drivers that you create, all the code like le.c, gpio.c, all these are all stable already, your application is a small bit and it doesn't take long. See, how big is my application? My application, the real part of application is just here to here. Okay, about a few hundred lines of code. How many hundred lines? Well, strictly speaking, I start at line 171, I end at here. And this is for a big system. That's the amount of code that I have. Why such a big system use so little code? Because I got a lot of all of these, like LED, ADC, all these, all built up already. Tested, all working properly. This is the main bit that I always need to change for different projects. So you can ask me how can I handle, why I can do projects reasonably fast. I can finish projects pretty fast because a lot of it has been built and I built it, so I know all about it. Now, I use Arduino also, you saw already. I can tell you that project just now you saw the Arduino one, this big project. Not this one. This one is actually the course that we run, we use this one. This is the whole thing that you're going to build. If you take the course with me through ASEM1, these are all the things that you'll be building. You are going to build the libraries. Of course, you will build the application also, but you learn how to build the libraries. You learn how to build the error. You build in the error system, everything. You build in the debug system as well. Now, where is the debug system? Debug. This one is in global. I think it's in sys. Okay. Sys error. Anytime you do sys error check, you will check whether there's a fatal error or not. If there is, it jumps there. Okay. So all of this is what you will be building as a foundation. Then the application comes. So this is the main part of application. BLE check state, heartbeat process, UART process, this one. So at the end of the day, the main code is here. And this whole thing is an IoT device. Okay, you build the hardware, you build the software, everything is here. The gateway is another code. Anyway, that is on embedded Linux. Okay, question is course divided into 2 sessions. One of those who has some basic knowledge of coding and those who don't. Okay. Well, the course is built so that you have practically no knowledge from beginning for you to start. Because ASEM would like to tailor it more towards those doing computer science and IT and computer engineering. But the course is long enough. I think you've seen the course outline that those of you from CS, IT, CE will find the first portion of it harder because there's more on the engineering side. But you'll find the second portion of it, which is on the cloud side of it, easier. Whereas engineers normally find the cloud side because they never do it before. So when the projects, everybody will be important. Each group will have multiple people from CS, IT, engineering, and so on. Jason asked, sorry, let me go to our questions first. I'm a little bit behind. I believe morning session is more beginner friendly. Were you in attendance? You mean this morning session? This morning session is all talking. It's not about giving you any of these. This morning session is all talking about the overall picture, what's embedded, and so on. Lim said, "Is there any chance to get a recording?" Ask Sam. Jason, any tips to avoid blocking delays? Yes, that's a very, very important thing. Arduino framework tends to be blocking. That means you want to read from serial port until a byte come in, only it starts moving. In real world, nothing of that sort. Everything must be concurrent. The aim is also to create a system that's fully concurrent, no blocking. So no delays. Delays are implemented differently. Delays are actually implemented using timeouts. Like for example, over here. Let's see. See the code I have. If sysdig bigger than ADC timeout, then only do something. Once every second, read the ADC. It doesn't wait. If it's, you see, if sysdig more than ADC timeout equals to sysdig plus 1000. That means once a second, it will do that. When the next time it goes to loop, sysdig is less than ADC timeout, it's not going to do anything. It just continues. So this is how we implement what we call concurrency. So you say you actually do the debug statement, make up significant storage given system. Well, this debug takes up about half of my storage because I put a lot of debug. But then again, I can also comment out some of the debugs as I don't need to use them anymore. And finally, I can remove all of it completely. When we build our systems, okay, when we start building our systems, we normally specify the highest end processor first so that we've got the most amount of flash and so on. But after that, when we know the exact resources already, we can shrink down. Working on processor is the same family, but maybe less flash, for example. So that's cheaper. Users and needs. So this is for those who has knowledge. No, it's not meant for those who have knowledge. Okay, you need basic knowledge, but it's meant to teach you how to build up the whole system, and it comes from the engineering portion to the cloud side and all this. So a bit for everybody. What else? The workshops aren't really meant for members or general public. Yeah, because I'm informed that the audience should be CS, CE, and IT and engineering. Okay, so it's not meant for anybody without you need at least a physics background or science background. May I know why blocking? Okay, blocking delays. This. No issue if you exit now, fine, no problem. What's concurrency? Doing more than one thing at the same time. Okay, if you got not a concurrent system, if let's say you use a LED whereby you turn on and then you wait for delay and then you turn off, between on and off you cannot do anything because you're just delaying. That's not concurrent. So in our system here, okay, our original system here, this is not concurrent, because our delay, when you are doing delay, you can't do anything else. So this is not concurrent system. So if you want to make a concurrent system, when the LED turns on, it turns on. After that, you can do other things. Then when it needs to turn off, it turns off. and then it can do other things in between. That is a concurrent system. So real systems are concurrent. Now, if you use Arduino, like Arduino, you can use delay, right? It's concurrent. So the thing you do it that way, we always have a time basis running. Okay, we always have a time base that's running, and when the time base is running, we can do whatever we need to do. Like first, okay. So this one is a different example, but let's say the Arduino IoT example. Now you can see here, this part of the code only happens once a second. So concurrent means you are running multiple times, multiple things somewhat in pseudo parallel. It's not true parallel because you only got one processor core. So when it's doing something, you cannot do anything else. But you don't want it to like do something and then delay. If you let it do a delay and it delays so long, and then you do another thing. In the delay itself, you can't do anything else. That is not what you want. So we have a time base. That's why the timer is very important. It creates a time base, and the timer is updated via hardware. So it creates a time base that you can use. Jason said, can SysTick timer variable overflow? Yes, it can. Yes, it can. But the thing is, if you look at how I define SysTick here, it's a 64-bit value. Okay, so not that it will never overflow, but by the time it overflows, the universe would probably have come to an end. 64 bits, huh? That's a lot. What do you understand about watchdog timer and my FIP? The watchdog timer for a reliable system, the only way, the or should I say the most reliable way of recovering from hardware bugs, the most reliable way is a watchdog timer. Let me repeat. I know my system slowed down. Watchdog timer. The watchdog timer is the most reliable method to reset your system in case you got a hardware or software bug that makes you get caught in a loop. Chang said, interrupt similar to timer. Timers can cause interrupts, but other things also can cause interrupts. And interrupt is just a hardware that, or normally hardware, or normally a peripheral, but can be software also, that interrupts a call to say something needs to be done. Okay, now, so I've covered roughly what I want to cover because I'm not sure how much can be absorbed in such a short time, but you can see here that the slides that you have, these are all based on the basics of it. And I added a little bit on the hardware side as well. Like for example, driving an LED, there are two ways you can drive it. You can drive it low to turn on, or you can drive it high to turn on. And also like roughly how to calculate the resistance values. Okay, so this one for an engineer, probably straightforward. But if you are in CS or IT or CE, maybe the first time you have to calculate that. Yong said, I'm an IT student specializing in web software development, but it happens that I also have a great interest in embedded. Do you think it's a great idea to start by going back to university to study degree in electronic engineering? I don't know. Now with all the AI out there, you may be able to pick up a lot of these basics without going to university. As long as your AI doesn't start hallucinating. Does learning all this necessary before becoming or working experiment for EE students? I think it's working experience. A lot of this should become along. That's why you ask some of the questions. I learn different techniques, learning styles, and all this. It's all through experience. Well, for us, you see, the difference why we are here and not doing the universities. Your university teaches you sort of like coding, to be frank. Very few will teach you like the level we are teaching you. Like, for example, the simple thing of like using a switch, okay, a specific way to turn on and off debugging. These are the things most unis do not teach because your lecturers at universities are teaching you the fundamentals, but not in real world. In real world, we use the fundamentals, but we use it in specific ways to help us. I give you an example, like for example, like maybe your lecturer may tell you never use GoTo. Okay, but I tell you there's certain situation whereby if you don't use GoTo, your code will be so complicated that you cause more errors. GoTo is a simple construct that can solve a specific set of situation. Okay, so things like that. And GoTo is probably will save you a lot of extra coding as well. Not only coding, but space and also execution time. Okay, another thing, like for example, those of you from computer science, IT, and so on, they may say that your lecturer may say, don't ever use recursions or recursive algorithms. Or sorry, apologies. Those of you from computer science, IT, and CE, your lecturers may say, oh, recursive algorithms look good. You write ones and it's elegant. But I tell you straight away that recursive algorithms can be very dangerous and we normally never use it. All recursive algorithms can be converted into normal loops. So what concerns me is that we are actually degree in electronic engineering, right? We know what we know. I cannot say anything otherwise on that. But of course, you got to course in ASEAN, into MBA what you're going to go through a lot of these extra things, and that will make a big difference. Because, as I say, we cover you see the topics is not say very far off university topics, but the fact is real world. And I come from the area that we implement for clients and our own and all this for the last 25 years. I've been doing well professionally for the last 15 years. So we build systems that are ultra reliable. Okay. Okay, I said working in embedded system probably after NCEP. Will I be involved in circuit assembly and hands-on, or focus more on coding, development, dealing with laptops? Well, if you look at the NCEP program, it's more focused. You have to build up circuits as you go on breadboard. But if you come and work like me, you can see that we develop our own circuits and so on. And just now you saw I got my own soldering station and so on and so forth. So yes, I do end to end. Like for example, okay, designing PCBs. Okay, designing hardware. I don't cut them myself, but I design everything and send to somebody who has a laser cutter to cut. So I'm not only involved in the software and the hardware. I'm also involved in the mechanical designing and case. This morning, I designed this one. It's an adapter, and then I 3D printed it. I designed it using Fusion 3D. So how many software that I need to use that I'm reasonably good at Fusion 3D, Adobe Illustrator for 2D for cutting. Of course, the compiler I use, the Q MDK ARM compiler. I use Visual Studio. I use, I'm just looking at the bottom of my screen what as I use OrCAD. I use Cadence OrCAD for schematic design. I use Cadence HPA layout for the HPA layout. I use a lot actually. I have embedded Linux. Okay, so because I'm a small company, I do everything myself. So when those last two batches that did their on-job training with me, they end up like doing everything. Some people did this, some people that, some did mixture of here and there, including a lot of experimentation. Because like you can see, like aquaculture, I need to do experimentation with chemical concentration. So yeah, I let them run experiments. So for me, I would say we do a lot of things. Okay, any other? Okay, let me get back to slides. Let me just make sure I finish everything on the slides. So I just cover a bit about 7 segment and so on. Then you got switches, you can detect high and low. These are more on the electrical side, as I say. And just now, what you saw was something called modularization, whereby you have more than one module. Of course, today only we got time to just do the LED alone. But in real sense, you can see that the ADC also we do, the other things like UART and all these also we modularize. And there are many, of course, there are many benefits of it. In real life code, right, it cannot be one person working on it only. Well, okay lah. For me, that's a different case. I started so long ago. I write my own. But the main thing is testing also. Once you modularize things, you just test that module on its own. So earlier on, there was a question, how you make sure that it's all correct? A lot of testing. I told you already, when I start a new project, now you can see that I use the processor, the same processor all the time. Okay. This one is the inside of just now, the one I mentioned to you. It looks like a pulse oximeter, but inside is our own circuit. We only buy the pulse oximeter because we want the casing. Casing expensive to make. So we go and buy the casing. We buy the oximeter. I think 2 ringgit, 3 ringgit only. After COVID, very cheap already. Then so we have inside, we build our own circuit inside. Okay. Now, so we build all this, then we build everything one at a time. We got so many components, we enable one at a time. When we write our software, we only control one thing at a time first. Make sure everything is tested properly before we move on. So we don't write code that's complicated initially. Okay, we write module by module. First time put on new board, run flash LED only. Just to make sure the board works, we run flash LED only. I know, as I say, it sounds like, oh, back to flash LED. Yeah, this processor, we know by heart, but it's okay. We run flash LED first. Make sure the hardware is also working. We all use that. So testing all this goes hand in hand. Straight away we test. Test. That's why it takes us time to build up. By the time we finish, normally they're very we don't build the entire software. Everything. Oh, $100. Don't know where to start. No. Step by step upwards. And key to that is building things as modules. So modularization is key here. Okay. And because we modularize it properly, when we switch from one processor family to a different processor family, say this one I'm using is a Nordic NRF family. If I switch over to STM32 family, the code is all written in C, but different family does things differently. An example is here. You see, 81 family, no I2C hardware, so you have to do manually. PIC micro family has I2C hardware. So we do it differently. But at the end of the day, when we write our higher level code, like test over here, we call I2C start, I2C write, no problem. Which family that we are using, we either use the lower level one from 1851 or the lower level from PIC. The higher level code doesn't need to change. That's why, like for example, Windows, x64 Windows, 64-bit Windows can run on your normal your Lenovo laptop, but also can run on Mac running the x64 Intel processors. So that's another major benefit of modularization. And of course, as I say, you work as a team. Each person in the team can handle a different module. They can test until everything is good. So this one I want to cover today. The reason is because a lot of you break things down to small chunks. You break things down to small chunks, much easier to handle. When you get a big project and you look at it as a whole, break it down the chunks and handle it individually. Okay, Sanjeev said, do you do lithography? Well, not on the IC level, although I can design the front end of ICs on FPGAs. Well, I can implement a lot of things on FPGAs. I don't do lithography. Okay, but if you're talking about like this is also a lithographic process. This kind of things when we design the circuit, yes, we send to China. Circuit and boards might be expensive while online simulator 2 is limited. What is the best way to learn embedded system? Because you need hardware to interact with. Get an Arduino. $100, you can learn a lot. Okay. You don't have a simulator or emulator, you still can do a lot of things. Yeah, I got an high-end simulator here. Yeah, it's pretty high-end. It's about a few $1,000 this one. But that's because I do it for my work. But most of the time, I don't even use the high-end features at all. In most cases, I just need what's very important for my work, an oscilloscope. So oscilloscope is something that I need. So for embedded system, oscilloscope is important one. Arduino Uno learning kit is around $30 with multiple sensors. Yeah, yes, it is. It doesn't need to be expensive. Software part is practically free. You use Arduino IDE and all this is all free. Okay, so it's not expensive. ASEM, when we do the training with ASEM, they will, if you want to buy the kit from them, it's $100. Okay, you buy the component on its own, it will also probably be 100 or 100 a bit more only. Arduino Uno $10 no lah, $30, 20 to $30 is more likely these days. $10 days long gone already. Okay. But anyhow, you can easily get a kit for a kit with components in it, with sensors and all this. Yeah, of course, it's a clone. The original Arduino board alone is 100 over already. But if you can get a clone on Shopee or wherever, it's all full of clones, then it's about 80 to $100 gets you a very reasonable kit. Okay, so I suggest your first timers, when you first start, of course, you use Arduino libraries because that gets you going. Okay, but subsequently, there are limitations to it. The core Arduino libraries are fine. They're all well written, but there are also limitations because it's meant to make it very easy to use. Okay, but third-party libraries cannot guarantee. Third-party libraries, we have seen issues with them. We even have, just now that project that I showed you, we use a third-party library, and the library has a bug in it that was so severe that it was supposed to set to 1. If you use a function, it's actually setting to 0 by mistake. But you cannot change the library because you change the library and they never and a new version comes in and they never corrected the bug. You end up with the same problem. So we actually had to manually do it ourselves on our side. We have to actually use it the opposite way. So all I'm saying is the core Arduino libraries, the functions have been around for ages, as we guarantee no problem. Third-party libraries, no guarantee. you're on your own. But that's probably the best way to start. Now, of course, if you join the RSM training, we will still use the Arduino, we will use the IDE, but as I mentioned to you, we are not going to use the libraries. We are creating our own so that you understand how to create the libraries. And once you learn that, you can do it for any other processor family. And you can also port your libraries to the other processor families as far as possible you can, because you're writing in C. And that would be fantastic, so that then you build up your own ecosystem. That is the best way, because once you know your own ecosystem, porting the high level, writing the high level code to do whatever you want, you understand your ecosystem very well already. It may take you a year or two to get there, but after that, once you get there, you're on a very stable ground. Okay, guys. I think I only have, well, these are the last few slides that most of it is the same thing. It's just talking about the modularization. That's why I say I don't plan to do more than that today, because you all come from very diverse background. So I think we have up to, well, 4:30 is a cut-off date, but anyhow, we a cut-off time, but I can go on until 5 o'clock with all the Q&As and so on. So you got questions and so on, please throw it up. What's the difference between driver and library? Drivers are normally specifically to handle hardware. Okay, libraries are just collection. Libraries can be drivers also. Libraries can be like cryptography, cryptographic functions. You put them together, a few functions, put them together, you get a library. Okay, so libraries are normally collection of functions that are doing certain things, like DSP. You can have libraries for filtering and so on. Okay, so drivers are specific normally to handle hardware, to control the hardware. Okay, and what we do some more is sometimes we interact with the PC and so on. So let me show you just now. You saw that we have this sensor here. Oops, sorry. Let me put it back together. And let me show you that this one is communicating over Bluetooth. Okay, this one is communicating over Bluetooth to my computer. And this one, I wrote the code is in C++ or Visual Studio's Visual C++, running off Visual Studio. You can see we can connect to the device. And if I put my finger there, okay, you see I got my finger connected. So start scanning. Oops. Oh, failed to respond. Okay, let's disconnect. I think it's in the funny state. Just now we got, okay, let me just reboot this fella. Okay, let's start again. Okay, I clip it on first. Okay, it's found the device. Connect to it. And then if I do a start scanning, you can see there's a PPG. So this one was done together for studying dengue patients to see when if they become critical. So you can see this one is like a pulse oximeter. Yeah, it's not far from it, but it uses multiple wavelengths to detect something called hematocrit count. So this is the raw values I'm getting right now. So okay, yeah, each peak is a heartbeat. You can see data coming here. If I remove it, you can see it goes straight line. Yeah, it takes a while to come in. There's a lag in between the two because I'm running at very high speed at the moment. Okay. So let me stop it first. I think the speed is too high. That's why you can't see. Oh. Yeah, Zoom is causing my PC to run very high loads for some reason. So that's why it looks very slow. But let me um, okay. It's not the hardware. It's actually because my system is running very Zoom is affecting my processor, and I think my processor is probably not running very hot. So it makes everything slow down. But you can see in normal circumstances without using Zoom on Zoom. Okay, so this one, no algorithm isn't built in yet to detect anything, but that's because after getting the data, after we build this for them, they get the data. Then once they finish processing the data using like MATLAB and so on, finally, when they find a suitable algorithm, a stable one is implemented back here. So subsequently, you can get the results from here, directly from here. So this is a common flow for developing wearable electronic devices, especially for healthcare monitoring. Okay, any final questions? Not sure how many of you are still there. It seems like they're still. The link to the slides, I thought every one of you have been given. Okay. Please contact ASEM for that. Is Arduino code considered firmware? Okay. Normally, I would consider it firmware. But if you go to different companies, like for example, Motorola, they don't use the term firmware. Anything that is software is software. Anything hardware. They don't have like hardware, firmware, software. Okay, I differentiate it because I also have to write like on the PC and all this, and that one I call software. Anything on the embedded, I call firmware. Okay, so depending, it's up to you. So you can call it firmware or software, but some companies only doesn't distinguish the two. They just call it software. Some do, firmware and software. Okay, do we use Arduino boards in industry? Now, this is a very big question. Arduino boards, 30 bucks one from Shopee. The thing is, it may not be reliable. The soldering may not be perfect and so on and so forth. Okay. Generally speaking, we don't use Arduino boards in harsh environments or mission critical ones. Instead, we can use the same processor, but we build our own boards. The Arduino that you buy off the shelf, it may be 20, 30 bucks only. And as I say, because you see, reliability has also hardware reliability as well as software reliability. Software is one thing you can settle. The hardware reliability side, like for example, the Arduino board, let's see, do I have one here with me? I should have. I have another version of it, but oh yeah. Okay, I got one with me here. Now you can see these two, right? Capacitors there. Most of the time, what breaks down in electronics is the capacitors. They are the ones that will degrade over time. When you buy a laptop, they give you 1 year warranty, maybe last 1.5 years. Why? 95% of the time is capacitors. All capacitors, especially this kind, the higher value electrolytics, they degrade over time. There's a degradation curve. First year can degrade as much as 20%. But after 3 years, they are very stable. You buy a laptop, they give you at least 3 years warranty. You will be quite sure it will last a long time, much more than 3 years. You buy a laptop, give you 1 year warranty, it will probably last 1.5 years. Okay. So if you want to use an Arduino board, you can. Either you make your own or you buy a very good one whereby the capacitors, everything are, the components are quality components. That is important. Okay. Like Raspberry Pi also the same. Raspberry Pi has its basic Pi, or you have the compute module that's industrial qualified. They are built, the hardware is mounted differently on the PCB. That's a big difference. Okay, so Mohammad Nazri said, how do you procure high quality parts? I only buy from 4 different suppliers. Mauser, DigiKey, Element 14, RS. Sometimes others I dare to buy from is Arrows, and who else? FNet. These few only. So buy from reputable suppliers. We bought before from China. During COVID times, there was shortage of components. We buy from China. Once we bought, when we open up, we bought ICs. They only give you 3 resistors, so $500 gone. Another time they said these are original, never use ICs. Came, we can see they remove the solder. Never buy from China. Also, Arduino board is meant for education purposes, not for industrial use. As I say, same as Raspberry Pi, but yet people will use, but they will use the industrial version. You can get Arduino boards that are industrial qualified. But they won't call it the Uno, of course. But it's still the same processor. You still program the same way. Everything is the same, except that they won't call it the Uno. What type of microcontroller used by industry? A lot of types, okay? Many types. Generally, nowadays, a lot of them are ARM-based, okay? ARM Cortex-based. But ARM only sells the core. It's other people that puts a peripheral around it and sell it like NXP, ST Micro, and all these. Okay? So majority are ARM-based these days. Muhammad Kiri say RS, yeah, or RS, yeah, okay, they are good, but they're expensive though. Arif, in your experience, what separates a good embedded programmer and a bad one? Ooh. A good one normally knows how to build things systematically. Test, build a bit, test, and so on as they go along. So that they have very little bugs and the code is very reliable. A bad one will jump into it, and after that, okay. Will we get this slide after this session? That's why I thought all of you have been given the slides. Ask Sam for it, okay? We will send out. Okay, Shaswan responded already. We'll send out once they receive their consensus. Yeah, I told them they can use the slides. Okay. Sanjeev said, this is also my experience, unfortunately, with cheaper products. Yeah, unfortunately so, but I can tell you majority of the time, as I say, is the capacitors. So for us also, we make sure that our capacitors, we buy the good ones. But not only good, but it's rated properly. Now, I mentioned to you, capacitors degrade about 20% in the first year, especially this kind of electrolytics are the worst. They can even degrade up to 50%. So if let's say, for example, you want something last at least 3 years, and at the end of 3 years, you need 1 microfarad, say. At the start of it, you cannot start with 1 microfarad. You probably have to start with 2.2. Then at the end of 1 year, at the end of 3 years, it dropped to 1 point something. You're still safe. But 2.2 microfarad costs more than 1 microfarad. Definitely. So that's why laptops, say for example, laptops, you can get the same spec laptop side by side, Lenovo and something else. It can be 20-30% cheaper. The 20-30% cheaper one give you 1 year warranty. The other one give you 3 years. Always go for 3 years. It's definitely worth it. Okay, if you can afford, go straight away. Go for those laptops that give at least 3-year warranty. Not those extra warranty also one. That's also useless. Manufacturer warranty, because they are really confident. Laptops have a lot of capacitors to control to stabilize the power. They have lots of them, and they are normally the passive components. They are the most expensive. Okay. What does an industry look like for embedded system? Any advice, warnings for those starting out? Very good question. 3 years ago, before AI came in, I said no issue. Nowadays, I said should be no issue for the next 5 years. I say should be. Okay, I cannot even guarantee. Because I myself, to give you an example, last time I sent out my Android code apps for somebody else to do. Nowadays, I'm doing it myself because I get a lot of on AI help. Okay, Lim Yong said, just a thought, how to design a circuit to work at 2.2 and also 1.1 after 3 years? Well, these are normally power supplies. A lot of capacitors are used for decoupling, and as long as they are above a certain minimum, they are fine. So they can tell you, the data sheet will say minimum 1 microfarad, but they normally also don't state, they say maximum maybe 10. So you put somewhere higher than 1, 2.2 or 4.7. Does medical devices uses a lot of embedded systems? Yes, a lot. Even your pulse oximeter is an embedded system, actually. So yes, the answer is a lot. In industry, does embedded engineers use AI to generate or debug code? 3 years ago, you better not, especially if you're fresh. Nowadays, frankly speaking, is generating very good code. I give you an idea. Microsoft have been laying off people, Amazon laying off people and all this. Microsoft themselves said 30 to 40% of the code now is written by AI. If Microsoft trusts AI, why not you? Could you teach how to properly use a data sheet? You have to understand what you are reading. There are some parts that are more critical than others, but you have to understand what you are reading. There are so many different kinds of data sheet out there. Like, for example, okay, for microcontrollers, there are those that the special function register side is important. If you take a transistor data sheet, the certain curves are important, more important than others, but all depends on what you need to use for. So I can't really say exactly, but the main thing is if you don't understand some part of the data sheet, the part that you don't understand, if it's not critical is to your work is okay-ish, but if it's critical, then you have to understand it. A solid problem-solving skill important for embedded. We are only solving problems. In embedded, it's a lot about solving problems. So, like for example, how you do, like recently we had to do, we got a measurement, but then that is what we collected in the lab, and then if we go into the field, the measurements will be up and down a little bit. How do we solve it? Okay, so we have to have the measurement, that's a curve, and two other curves, the boundary curves. And we have to calculate how far are you from boundary and all this, so to give you a percentage of confidence. So yes, it's a lot about problem solving. Can you suggest an embedded project using Arduino ESP32 to showcase my embedded skills in my portfolio? Project. Weather monitoring? Is a multi sensory thing. Okay, we are also supposed to give projects in it, and I've listed some down already. That's not all, but I listed some down. There can be a lot of different projects. Even creating a microwave oven controller is also not so straightforward. You may think, just running a microwave and so on. What's so hard? That's the problem. When people say, what's so hard? After you dig into the details, then you realize it's not so easy. You have to detect door switch, this and that, and so on. Does entry-level job for juniors still secure since you mentioned AI already generate good code? AI still needs people to prompt it to generate good code. Now, 5 years down the line, I do not know. Okay. But until now, you still need proper prompting to generate good code. So if you cannot prompt it properly, it may generate good code, but not what you want. In Malaysia, do embedded software engineers get paid with a high salary? I know people who are definitely paid 5-figure salaries after about 7-8 years on the job. I myself had hired master's people at 6.5 starting pay. And I hired a PhD before in the past, and that starts at 9,000. So I give you an idea. Bachelor's degree, I've started at 4.2 before, rising to 4.3 after 4.5 after confirmation. Okay, so that's the range I given before. Why do you want to program an ALU in Verilog for embedded? Most of the time, embedded is more on the usage of the system already, usage of the chip rather than uh, what you're talking here is more suitable for IC designers, ALU side. The embedded software engineers have greater job aspects at other countries like China. Not been to China, so I can't really say that. But definitely, embedded is also a big. There's big opportunities in Singapore because I have friends in Singapore doing embedded. Okay, now we don't talk about embedded, but most of the software written nowadays there's embedded and there's also embedded Linux with RTOS and so on, which is very close to desktop. Okay, deep embedded ones like without our OS one also we do, but that one needs, I would say, more skill because you don't have the OS to help you. When you don't have the OS to help you, you cannot even printf is also a different thing, printing to a if you got OS to help you, you print a screen, no issue. You got no OS, you got no screen, where you want to print to? Serial port. That also takes things to do. Random question. Pursue embedded. Is it better to undergo course to improve skill first or join fresh college graduate trainee? Ooh, not so easy to answer that question. Is it better under course to improve skill first? Because you need some fundamentals, so you probably need to be a graduate before you get the skill. Because like for us, what we concentrate on is the higher level already that unis don't teach. Any job interview tips? I think I skipped that question. Means we need to be good on AI prompting. Well, AI is like a child, a 3-year-old child, but a very smart one. But you still need to prompt it properly, or else you may get the wrong things. The electronic manufacturer company look for employers with high. It depends on the electronic manufacturer what they are doing. If they are doing R&D, definitely they need very high microprocessor embedded skills. Okay. If they are doing assembly and all this, there's a different one. Okay. Does embedded systems use ROS? What do you mean by ROS? This one need to know. In embedded programming, how do engineers or we do version control? Okay. Either you use things like GitHub and so on for your version control because you're sharing projects with many people, or like me, because I'm mostly doing only on my own, my version control is like this, which is primitive, but it works. Let me see. Let me get a. Okay, I got software, hardware, version control, and so on. But my version control is primitive. I copy all the files across. And I just specify, okay, this version has what, and so on. Okay. That's good enough for me. But of course, when you're working in a big company, that's not good enough. Okay. But we do some version control. Or else, after a while, when you're running 10 projects at a time, or you have to go back to an earlier project that you have not touched for 1 year, you need to know what version numbering you have. What version does what. So yeah, basic definitely needed. As an embedded dev, do you need to be familiar with ROS or ROS2? Yeah, what is ROS? A lot of acronyms, not all I know. robot operating system, uh, I build my own, or at least I build my own libraries. Even the OS also, I build my own OS before. Simple OS scheduler, okay? Yeah. So all of these are tools only. You don't need to know the ROS or what, but you need to know roughly how OS works. Then you can target FreeRTOS or whatever, because almost all OS, majority of OS has very similar functionalities, multi-threading and so on and so forth. Is mastering RTOS is a must to meet industry standard? No, but it helps. Okay, you don't need to be a master, but you need to know RTOS concepts like multi-threading, preemptive and cooperative scheduling, and also like normally blocking processes or semaphores and all this. Those are the few things that you need to know. Once you know all those, then you know how to think, you know how to break down a problem into multiple threads, then it's easy to go about. So I have done before, like for example, doing GSM up using GSM or 4G or 5G to upload data using a modem, as well as collecting at the same time. So there are two separate tasks that are running concurrently. So I've done it before without an OS and with a lightweight OS. Without an OS, you have to make sure that if both sides are running concurrently. So one side stops, the other side will run. Once the side have to wait and then this side run. But you have to do it manually. With an RTOS, you code both sides without needing to worry about the cross between the two. You code both individually. So it makes life a lot easier. Okay, of course, the RTOS has a little bit of overhead. So horses for courses are normally it's better to have an RTOS once you have like multiple threads that you need to run or multiple tasks that you need to run concurrently. If I try to build a full prototype of automotive ECU board at home, can Arduino Uno support this project? Automotive ECU? No way. They are very complicated. No way you can use an Uno for it. You may use other Arduinos, but Uno cannot support this. Unless your ECU is so simple that you get accelerator value and you just control the throttle. Maybe yes. Apart from that, probably the Uno cannot handle. What is your favorite microcontroller to work with? Well, we use a lot of the Nordic Semiconductor nRF52 family because quite a lot of ours involves Bluetooth Low Energy. Okay, so the other processor family that I'm fairly familiar with is the STM32, but they are a little bit harder to configure. But they have features that are very suitable for power management, deep power management. So those are the two families, and they cover a lot already. Okay, the problem is we deal with ARM a lot, ARM processors, but ARM only builds a core. So whoever go and build the peripherals, they have their own way of controlling. Like for example, NXP would have its own way, STM32 has its own way, NRF has its own way of controlling the same peripherals. So you need to read the datasheet to know how to control them differently. So that's a slight problem. They're all ARM devices, but ARM is only the core. Okay, I think it's almost time already. If you got any last 2 or 3 questions for me to answer, then after that we call it a day. For purpose of portfolio building, should code adhere to industry standards? Okay, this one is an interesting thing because technically there's not much standard for coding. There are guidelines like the MISRA guidelines and all this for coding, but not so much of standards. Standards is more for the entire system. Medical devices that we also do have standards, and depending on the class of device, we have to have the code at a certain level of standard. Okay, but it's more like a recommendation rather than standard. How about RISC-V based microcontrollers? For me, it's more like as long as it's something that is used, can be used, not too power hungry, I'm fine with it. I even use big microcontrollers. Why I stick to certain ones is because I built out a big library already for it, so it's fast for me to work with. So I still stick mainly to the NRF 52832, because I'm very familiar with it. But it doesn't mean that I can't use RISC-V or what. It's just that, oh, probably I have to go back a bit and read up and find out how to use it. So if customer comes to me and say, oh, we want project, this is spec and so on, I specify the processor and all this. But if they say I need this specific one for certain reason, then you have to charge extra, because I say, okay, this one I'm not familiar, I'll charge you extra. Go broad or go deep for getting into embedded systems. Embedded is very wide, so you probably have to go broad, but you probably need to also specialize on one or two families. Okay, so yeah, I can handle so many families, but my specialty, I specialize mainly on NRF family. So my next best one that I know quite well is the STM32 family. And another one that I also know fairly well is the NXP family. Apart from that, I'll probably have to read up. Big Micro I've used in the past, so I know roughly how they work, but that's a long time ago. How can we access the aptitude test, or is it done? So this one, you ask Sam. Okay, I guess one more final question, then it will be 5. About standard accuracy of medical devices. Is there a document that we can refer to, or just require a test you to take the accuracy? Certain devices, depending on device, different devices, certain devices may have ASTM standard attached to it. Like for example, thermometers, IR thermometers have to have an accuracy of better than at least 0.5, I think, or even 0.2 degrees. So that is specified by the ASTM standard. Okay, so some devices, yeah, there are standards, but I do not know about everyone. Like for example, SpO2, I don't think there's a standard for oxygen saturation, but definitely for temperature, yes, ASTM standard. Okay, I hope you have enjoyed this brief workshop, and I know I talk a lot about other things also, because I want to give you an overview of what it's like to be a hardcore embedded engineer. So that's why I go all over the place here and there. And I also want to concentrate on what I think is very important that you can cover in just 2 hours or whatnot. So I hope you have a reasonably good overview. And of course, I'm going to, Sam has a training that's coming up in April. They are all specified by me. So if you are keen, you can join it. Hopefully they run it, and then I'll be training you all for like, I think 25 days, including the project. Okay. So thanks to all of you for taking your time also to participate.
Okay, thank you, Dr. Royan, for the insightful sharing about the overview of embedded system. So I guess we are moved to the closing. So I guess everyone like giving the give the questions to you.
Okay.
So if anything you want to know about regarding today's training, you can just drop in the chat box, and then we can see if we can answer it. So before we pause, please scan the QR code. There is a QR code for the feedback form. Wait a second. Yes, as for the slide, we will give you after we done the training, and then we're gonna send it through your register email. Later. Okay, sorry, can you see the QR code? Oh, not yet. I guess there will be. Okay, okay, there's a QR code for the feedback form.
Just
So
have to very-
yeah. By completing the form, you will receive your e-certificate, and your feedback will help us improve and plan even better programs in the future. So inside the feedback form, we have 4 quick questions that we want you guys to answer. One of it is, who was your favorite presenter today? So we had fantastic speakers as today before the workshop, which is Dr. Saleh Ahmad, co-founder of WeRock, and then we have Mr. Simon Huang from NSP, and then we have Dr. Shan CEO from Alpha Swift, and Mr. Kota Badusha from USD. So you guys can choose which one is your favorite presenter for today. So for the second question, we have, which session did you enjoy the most? So was it modern products are system, not just software? Automotive, robotics, drone, medical devices, smart hacker, and how do you become one? So the third question is, which workshop interests you the most? So this one you can answer by depends on your idea. And then there is last one question is, what topics would you like to see in our future events? So if you want to give us any idea about any future events that you want, you can drop in the feedback form so we can see if we want to run the events with your idea. So it will only take a few minutes, so you guys can take your time to answer. So thank you for your cooperation.